We're trying to get started here, but I can't get this video to go away, so please stand by. Okay, yeah, I don't know what was going on with that, but the video would not go away. It took control I think we're good now. So thank you, Martin, for just saving my hide. Hello everyone. Jason McDonald here with this block of Pyjamas 2022, the coziest Python conference in the known universe and part of the unknown universe. So it's pretty cool. And I'm joined by my very noisy co-host, my dogs, who you will see inevitably throughout the video. So coming up first, in just a minute here, we have Trivka Carper. I probably just messed up that name. And he'll be presenting about building custom data applications under insane expectations. Before we get to that, though, make sure that you join our Discord. Links down there in the ticker. And there's a giveaway for a book down here as well. So make sure you have entered that raffle to win that. But with no further ado, I'm going to turn this over to. Should I give? How do you pronounce your name correctly? Because I'm messing this up.
My parents weren't that internationally minded, I guess. So it's Trygve.
Trygve.
Yeah, that's right. Yeah, it's almost perfect.
Trygve. Nice. Yay. Thanks. You only have to do it once. Excellent. So I'm going to turn it over to you and take it away.
Yeah, let me see if I can share the screen here. All right. So, so I'm going to talk about a period of my life where I worked for a Norwegian startup. So for about 4 years of my life, I lived and worked for a company called Cognite that was a startup. So I started there when we were basically zero. I was employee number 30. And over those 4 years, we grew to 700 employees. That's when I left. And that company was a company that is building like a product which is somewhat like Snowflake for industrial data. So delivering a database in a way, data warehouse, but for industrial data. So things like time series and sensor data and 3D models and seismic data and not that much tabular data. Over those 4 years, we were trying to use like machine learning and analytics on top of this database in order to help very, very big companies stay profitable, basically. So it was a company that where the second customer was like BP and the third customer was Exxon. So very good sales leads there, but it also gave me some insight into what these companies wanted to achieve with that. And basically, they've been looking at the success of companies such as Amazon and Google and Facebook and looking at what they did and how they used data and more digitally native ways of working in order to deliver value in a different way. And they were doing a lot better than they were. And they were all thinking that in like 10 years, we are not profitable anymore. We have to do something. How can we do something? We don't have the people. How can we like do something for real in order to like stay profitable? And looking for partners, and they find companies like Cognite in order to come and help them. And this is kind of how the insane expectations are set, because it's somewhat of the lines like, if we give you $10 million, can you deliver like $1 billion back? That's kind of the setting. So I thought through this talk that I think that there's a lot of people talking about becoming data-driven, going data-driven, using machine learning for business and how that's important and so on, but no one is like talking about what is actually done in practice, right? So there's tons of like management type talks, and there's like zero on like what actually happens. Well, how does it really look like, and what's the nitty-gritty? So in this talk, I thought I'd talk a bit more about that, basically, like what really is it that we're talking about. So how it happens in practice is that these people have figured out that we need to change in order to stay profitable 10 years from now. They look for a partner. They some people like also advertise for a partner in the sense that they do like these RFP processes, like saying that we need this and that. Can you like compete for giving us an offer? Whereas others are like actively searching through their networks, trying to find some company that they can talk to in order to help them like change how they work and look cooler and stay profitable. And when you start that dialogue with these companies, then it's typically like top-down digitalization initiatives that comes out of it. So you sit on the top level and you agree that, yeah, okay, so let's identify the most valuable cases that we can do in our business to like increase profits or cut costs or avoid manual labor and so on. And this is like typically a conversation that starts pretty high up and then trickles down. So starts at the CEO level, then trickles down to the different business lines at the VP level and down all the way down to the business lines. And that's matched by the company who's kind of the partner in this case, which was Cognite in my case. So I came in at the VP level myself, and I had a team of data scientists going into deliver, and we were like talking together, what are the like best use cases that you have, and they were talking down and finding that. Then it was to scope these projects into like chunk size OK projects, find a way to staff them, and then execute. So very top-down initiatives that we did across like BP, Exxon, and a lot of other big energy companies, not only oil and gas, but also like power, hydropower, and that kind of thing. And then it was to execute. So I thought I'd talk about what the hell is this in practice, and that you would maybe find that somewhat interesting. So the first case we did back in 2018, it was like December 2017, January 2018. So I know that many of you maybe know this world a bit and that it has gone forward, but I thought I'd go back and see how bad it was. So back then we were getting a case on an oil and gas compressor. I don't know how much you know about the by now very shunned field of oil and gas, but basically, in order to transport gas along the big distances, you need to compress it, right? So that you build up the pressure so you can transport the gas over a significant distance. Now, at especially offshore oil and gas rigs, that's very important in order to like get the gas off there and into the shore. And when that oil and gas compressor shuts down, then you have to stop the entire production. And the production at such a facility costs like millions of dollars per minute. And they don't see it as kind of, okay, but then we will extract that oil and gas later. No, they see it as lost revenue problem, more or less. So they had a problem where this customer where they had a compressor that shut down from time to time, and it took them some hours to get it back up. We were asked to provide early warning on that, and if they were getting an early warning on that, they could like schedule maintenance in a time period where it was better for them and have the parts ready and so on, and then maybe cut the downtime in half. What we had to work with was like sensor data, so there are sensors all over this place. It was prior events that had happened and a lot of technical documentation. So what did we do? So back then, we took 2 data scientists and a project manager from our end, working on this for like 3 months. From the customers, we said that, okay, it's nice if we could talk to someone who actually knows anything about compressors in oil and gas and so on. And they put off a person with some time. So we had like weekly syncs with that person, and we were just talking gibberish over Google Meet for some hours every week. And then we were saying things like, yeah, what do you think about this model? It will tell you blah, 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 blah. And he was saying like, yeah, no, that sounds reasonable. And at the end, when we were done, we had built like a clustering model. I don't know how much data science you know, but we built like a clustering model that tells you that this is normal operations and this is like abnormal. So 2 clusters, abnormal and normal, and tuned kind of the threshold to previous events. And then we deliver that. What happened then was that this thing went into production. So we had deployed that model in Databricks, of all places, running and sending then email notifications to the users. What happened was that after 3 months, the compressor was acting so bad that it was shaking so much that the people were like thinking that this thing is going to just jump off the whole platform. But the model said nothing. It didn't capture that event whatsoever. Then the next month, like after that, we tuned the threshold. And then it had like 7 false alarms for 1 month, and then it was shut down, the whole project. So it wasn't used anymore. So on the left here, you can see the solution that we had. So we had data sources that were plugged into this database of ours. And then we were using Databricks as a way to get code running and checking something. And then we were using Grafana as a way to plot things. And we were using SendGrid as a way to give alerts. That was our entire solution that we got up in like 3 months. Didn't go very well. Next, after that, we were asked to do that was a year later, that we had like a valve monitoring case. So on these oil and gas facilities, there are tons of valves, like in the tens of thousands, the valves. And they have to be inspected, because if they leak, that's a problem. So they have to inspect them through like checking closing times, opening, and there's like a lot of regulations around what they need to check about that. When you see like how many inspections are actually results in something, and how necessary are they, you're going to find out that like 99% of inspections are just pointless. No need to have them at all. So this is of course a big cost, and it's a cost for different reasons than you might think. It's not the time that you walk around and spend inspecting them. It's that you have to actually shut down parts of that production facility in order to do the inspection. That's the most costly part of it. You have to plan a lot in order to reroute things around other places, and you need to reduce production and that kind of thing. So we got a task of like notifying which valve to inspect. Again, we had like sensor data, prior reports, and documentation, and the thing was to build something where they could get like notified, please check these valves and don't care about these. So again, you can see now that we've grown. We learned, like in the past project, we delivered something and it failed, like flat out. It was like pointless, gave no value at all. So this time we insisted on co-locating with the users and working like super close with the domain expertise and the users. So this time around, we had not only one domain expert, but we had like one expert leader from the management team at the customers, and we had like an actual user who was doing inspection on valves in the team. We had 2 data scientists and a project manager, and we had a data engineer who was like backing up from time to time. And these people were working together, co-located for 4 months, working in like agile 2-week sprints with like insane demos, insane pressure. So every 2 weeks there was a demo, and when it was a demo on these kind of things, then these demos were live streamed to the CEO of a company like Exxon, like following this. And after that, we did like a short rollout to all the facilities and a handover. So we had learned something in the sense that we were staffing it a bit more and really close with the customers in order to try to avoid creating the wrong thing. The solution we got was that we had exchanged Databricks for now Google Cloud Functions instead, and Grafana wouldn't cut it as like a overview over a lot of valves. So we were using Plotly Dash. This is before Streamlit in a way. So it's before Streamlit was announced. So we were using Plotly Dash and deployed that ourselves on Kubernetes. What happened was that once this project was complete and it was handed in, then it was never used. And that's very, very interesting, no? So we had actual users in the team giving IDs, saying that this is what we want, testing it and so on. They were part of the team, but what we didn't do was to get actual buy-in from all the other users. So if you have, it's not enough to have like a user in your team. That user becomes part of your team. It's not really a user anymore. You need to actually have it like in the business line with the users who are going to use it in actual settings, which was a big learning for us. Then the year after, we had another case on like maintenance planning. So when they plan what to do maintenance on, it leads to that you need to shut down areas in order to do that maintenance. And one of the bigger problems they have is that they don't know they're not able to plan so that they should do maintenance on several things within the same area they shut down in a way. So the task we were gotten was to build a planning tool that optimizes that. The data we had was like maintenance records, sensor data, 3D models, and technical drawings. We needed the technical drawings in order to figure out which area it was that we were gonna close down. And this time around, we've really grown, because now we had not only the same setup as earlier, but we also had a front end dude now in order to like really take one step further in order to get that UI up quickly and be able to iterate with the users in the business line themselves. And we had supplied an infrastructure dude in order to keep it up too, and a data engineer. The solution you can see on the left, and you can see that the Plotly is now been replaced with like a full stack front end stack. And that project is actually still ongoing. So it started in 2020. It was like scheduled to run for, I don't know, like half a year, 10 months. But the reality is that if you're going to develop something like this and have it actually be used and so on, you can never leave it. Still continuous co-location and agile 2-week sprints. And it's a long continuous testing period, because after 10 months, it was actually given to the users. And then, of course, that's when the real work starts, right? So what we learned over these years was that for the first case, domain competence is an actual must. Like we were sitting, data scientists and a domain expert, but separated, and just talking online for like every week. It's not enough. You're not able to like build the right thing in that way. Like talking over Google Hangouts isn't enough. And the second time around, we learned that even though we had that domain competence and the actual users as part of the team, it didn't get any buy-in in the actual business and were never used, even though we had the users in the team. So you need an extremely tight collaboration with actual users. And for the last project, we learned that we can never let the project go. Maintenance has to be easy to do, right? So like the maintenance load just keeps growing. And the whole thing here is about like time to first user interaction, because that's when you learn what people actually wants to use. But what we also saw that like teams became big teams, and iteration cycles became super slow. Like when we started out, you could do an iteration in a week, right? But with a big team, it's like 4 weeks. And the maintenance load just grows and grows and grows and grows. And still, it's difficult to build the right thing. Still, no guarantees for people actually using it and getting any impact. But that's not so strange now, is it, right? Because if you're going to build a data app, that's not only about building the right user interface, it's also about doing the right modeling and analytics. It's about modeling the data, and it's about testing and getting feedback from users. It has a lot of components to it. So when you get something out and you see that the users don't use it, then there's a lot you need to iterate on, right? Okay, so that was not the right way to go about it. I need to create a new interface. Maybe this is better. Then I need a new modeling type of thing. Maybe we need new data, and then that's a big thing. And when that is scattered across a big team, like there's different people doing every part of this, then how many iterations can you actually do? It's super hard. It's very, very hard to get something out the door that actually users want. And then this top-down digitalization approach, where you like first determine the project, then you scope everything out, and then you start this, then you need things to be so valuable that it's so hard to do, right? So actually getting your ID that you know out the door is super hard. So how many IDs does really get tested, right? Super few. And how valuable does an ID need to be in order to like kick off a machine like this? It's very, right? It's in the millions of dollars in like savings per year. Otherwise, you could like forget it. So how much potential are we really squandering, right? How many like low hanging good ideas are there that we could have just tested and would have been better? So in 2021, we quit Cognite and we started DataButton in order to like try to do this in a different way, like get up some tooling, deliver some tooling that could enable data people to do it all themselves. So with DataButton, we are creating like an all online workspace, all Python, making it like super easy to go from an ID to an actual data app. And the whole point, what we are optimizing for is like to get up that first prototype super quick so that you start getting user interaction and you can iterate. And to keep it like super easy to maintain and to keep it like actually up. So thank you. So I think I'd say that through my 4 years, I'd learned that top-down digitalization is expensive and rarely works. And I think that we need tooling and the proper people in the right places in order to have it more bottom up. See the opportunities that are there and actually being able to build something quickly and test and see if that works. So thank you.
Yeah, I've been muted this whole time. I'm sorry.
Oh, sorry.
That's why my mouth is moving and no words are coming out. So I was saying thank you very much for that. And if anyone wants to ask any questions, ask over in the live chat there or in the Ask Speaker room, and I will relay those questions.
I would like to say something. I hope
Yeah.
people what you can find when you talk about digitalization, data science, and machine learning, and like these kind of initiatives. I think there's almost no people who talk about what they actually do. Right? There's so much like general advice and like you should do this and that and not that and so on. So few is talking about how the sausage is made in actuality. There is nothing to be found, right? There's either like how do I model this kind of thing, or it's like you should work agile with like blah blah blah. There is nothing of people who actually talk about how the sausage is made in these kind of things. I think this is my encouragement to everyone. Start talking about what you actually do, because I think that will liberate this thing.
Yeah, absolutely. Yeah, there's that thing where when we're creating content in the community, I see that it's either the very general, especially beginner stuff. It's like here's how to code in Python, and here is how to create a machine learning data model on an Arduino in your grandmother's basement to recognize pictures of cats and distinguish them from pictures of continents. You know, it's either hyper specific or hyper general. And yeah, you're right. There's a lot of that practical stuff gets kind of falls between the cracks.
Yeah, so I think like if you look around around, there's so much like imposter syndrome going about it. It's such a hard job, and people don't talk about what they actually do. And I think it would be a lot better, and people would feel it a lot better about themselves if they actually knew what people were doing out there. And we could get forward anyway.
Yeah,
Open up.
absolutely. Talk about what you do and talk about your mistakes too.
Exactly.
Yeah,
I
awesome.
agree.
Well,
So,
if anyone has any questions, Beregve, did I get it right? Beregve is
you
going
did.
to be in Discord, so hit him up there. And yeah, awesome. Thank you so much.
Thank you. Okay.
All right, we got Alex coming up here in a minute, but before we get to that, so in case you're wondering, that's going to be ScanWalk writing an extension module with CFFI, Python, and Plain C. So he'll be talking in just a minute here, and then later on, We got the real-time analytics stack by Mark Needham. So, and plenty of other cool talks coming after that. So stay tuned. Also, there's a raffle going on for this book that some weird guy that keep letting back in wrote. Anyway, so if you want to win a copy of this book from No Storage Press, enter there. And one of the questions we've been asking on that survey is, what would you like to understand better in Python? So I've been looking through some interesting things. How to remove the GIL and make Python faster. That one's interesting because the GIL, or the global interpreter lock, a lot of us think that's what keeps Python slow. The funny thing is, there have been attempts to remove the GIL, and they all result in Python being slower. So that's an interesting topic. If you look at the history of trying to remove the GIL from Python, that's a fascinating piece of history right there. But they are working on making Python faster, and strangely have not had to remove the GIL to do it. Few people, actually quite a few people have said machine learning. They'd like to know how to do machine learning in Python. I'd like to know how to do machine learning in Python. I don't particularly understand that one myself, but it's a deep topic. There's another book from No Storage called Deep Learning in Python. That's kind of cool. So if you want to learn how machine learning works there, but that's a very deep rabbit hole, machine learning. Fascinating, but surprisingly complicated. Even if you're an expert in programming, it's going to just blow your mind the first time you look at it. So, yeah, this is a great opportunity. Got 2 minutes to go refill your coffee before Alex joins us. I see he's waiting there in the wings. So, if you need to refill your hot beverage before this, now's a really good time to do it. And only a minute or so to go, so I'm just going to keep talking. And to answer Taneem's question, yes, I did put the link in announcements a little bit ago, so that is there now. So anyway, so we should start seeing. Well, we've been seeing people trickling in, which is cool. So yeah, so if you did just click that link and you're going, what is going on? Who is this guy and why is he talking? My name is Jason McDonald. I'm your host for this session. We got a lot of cool talks coming up, and I am here with my my canine co-hosts, which are being blocked by the chair. There's Monsieur Cordon Bleu, and there's Lady. She thinks she's a cat. Don't ask me why. So they will be making regular appearances, I'm sure. Because as soon as they get done with their nap, they're going to be like right here. So it's kind of fun. They work with me in my home office, so during meetings they'll be right there in the middle of a meeting with a major client, which is really hard to keep a straight face when you're talking to someone at a Fortune 500 company and you've got a dog licking your ear. It's a weird experience. You get used to it after a while. So, it's okay. It's the only coworker I would want licking my ear, just for the record. Yeah, Alex, I'm going to go ahead and add you to the stream here. Got about a minute to go. Hello, hello.
Hello, can you hear me?
Yeah, we can hear you.
Excellent.
Great. Awesome. And I see your screen share, so I'll be able to add that in a moment. Alex Wilmer. So there's no bio on the website. Are you anonymous or?
No, just probably forgot to fill it in. Alex Wilmer, I go by Moriarty in a few places. Chose the name ages ago. Just stuck with it. I'm a Python developer, Ansible developer for a company called CGI. Nothing to do with computer graphics or web servers. We just do IT consulting. Scanwalk is slightly the result of working with Ansible and trying to accelerate copying lots of files.
Fun. So before I add your screen, what's in the what's? I'm just kind of curious. What's in the mug? If you're going to be drinking something hot to warm up, what are you going for?
Just generic cola.
Okay, there you go. Pepsi or Coke? Not to start a war.
Pepsi, I suppose, but it's like those soda stream things that you buy the syrup and then you add it to stuff you've squirted with gas.
There you go. So artisanal. It's artisanal cola.
Okay.
Because you're doing it yourself, therefore it is artisanal branding. All right. Well, Alex, take it away.
Okay. Thank you very much. Hi, my name is Alex. I am from the UK. I do Python development and big data with a tool called Ansible. In doing that, ran into some very large directory trees that needed copying around, and by a circuitous route came to write this package called scanwalk. It's still in alpha phase, but the idea behind it is that it is an alternative to the built-in Python standard library function called os.walk. Does the same thing as os.walk, just presents the results in a slightly different way, which I think is more Pythonic, if I can be so bold. So the idea is here, live demo time. Hopefully the demo gods are with me. So standard Python 3, import the OS module from the standard library. And if I want to look at the contents of a directory, I can do for parent, there's files in os.walk demo. Then I need to do an extra layer of iteration here for the in DIRs. Oh, frig. Can't type. Bear with me 1 second. And that will print out the contents of this demo directory, just to give you an idea of what that looks like. A couple of directories called dir1, dir2, and inside dir1 we've got 1.1.2 and some files. If we want to do the same thing with scanwalk, which is the package I'm presenting about, then we can use one that I installed earlier. There we go. So the difference between os.walk and scanwalk.walk is that whereas os.walk returns these tuples of parent, what directories are in there, what files are in there, scanwalk.walk returns a flat iterable of dir entry objects, and dir entry objects have attributes such as the name. So the name for each of these, that would have been dir2 or dir1.1 or file A. And they also have the complete path. So this makes scan walk easier to use in situations like list comprehensions. If I want to, I can do and it's just quite convenient to walk an entire directory tree and get a list of the paths. This is a bit more awkward to do with the built-in os.walk function. So that is the essence of scanwalk, and the reason for its being. Those of you that have used the standard library function os.scandir will probably recognize these dir entry objects. And as you rightly guessed, scanwalk essentially is a thin wrapper around the os.scandir function. So os.scandir comes with Python out the box, part of the batteries that are included. It returns these os.dir entry objects, but os.scandir just works on a single directory. It doesn't walk an entire directory tree. That's essentially the point of scanwalk. It is os.walk if it had been implemented after scandir existed. Now, scanwalk is currently a pure Python package. What that means is it will work anywhere that Python works, but it is not as fast as it could otherwise be, and it has to do a couple of underhanded tricks in order to work within the confines of what os.scandir allows. So as an example of this, if I, instead of building my list of things, I build it with the actual dir entry objects using the currently released scanwalk, which is pure Python, we see a bit of a cheat. The first one, the one that represents the directory itself that we're walking over, is this thing called a fake dir entry. And that's because it's fake. The others are the result of running os.scandir. But because of sensible restrictions on the os.scandir function and os.dir entry class, pure Python can't make its own dir entry objects. What I mean by that is if I import OS and if I try and make os.dir entry object, I'm not allowed. And that's an intentional behavior of Python. It's a design decision and it's a sensible one. But to get past it and to be able to have a single, an object that is the same across all the elements in os.walk, it's necessary to drop down to the C level. And that's what I've been experimenting with and what the remainder of this talk will be about. So, the first attempt to do this was to take POSIX module.c from Python, from CPython, the default implementation, find the parts that implement os.scander and just copy and paste effectively. So POSIX module.c is a large file. It implements a lot of the stuff you see in the OS module when you're running on Linux or Mac OS. And the scander parts are just a small part of it. The attempt to do that is not in any released version of ScanWalk, but it does exist, as do the others, as branches of the ScanWalk repository on GitHub. I was feeling whimsical that day, so I called it Franken POSIX module, because I'd just taken parts of POSIX module, ripped them out, stitched them together, and tried to make a shambling beast. This is a Frankenstein's monster of how you would write a C extension for CPython. You have the full flexibility. This is using the raw Python C API. And if you are just trying to, you're just trying to make a small extension to an existing Python library that happens to be written in C, this is a reasonable way to do it. But you do suffer certain restrictions in that parts of the Python standard library are written in the knowledge that they are part of Python, so that they can take certain shortcuts that a external C extension can't. And this has the full flexibility of the Scander implementation that is in CPython, but even just the bits for Scander come out at 2,500 lines. It's quite a lot to understand and to tweak, and if you wanted to maintain it across versions, it would be somewhat of a maintenance burden. So if you need the absolute flexibility, you can use the Python C API, but you will be tied to CPython, which is the default implementation from python.org. You will find it a harder time to make this available for other implementations of Python, such as PyPy or Jython or others that are springing up. So this was my first attempt. I'm still referring to it, but it is unlikely to be the design that I will be going with. The next attempt uses a package called CFFI. This is available on the package Python index, and it is come out of the PyPy project. So that's the Python on Python people, PyPy. It has the advantage that what you are writing is mostly Python. You're not writing much C. And it's particularly good if what you're doing is just wrapping some existing C code. So we can have a look at the result of using this. That is the pure Python one that is the current release. That's the dir entry and the fake dir entry. This is what we're trying to get rid of. If we have a look at the, where did it go? There. If we have a look at the CFFI implementation, it is across two Python files. Scanwalk.py is an evolution of the existing pure Python scanwalk.py, and the changes are rather minimal. It still has the fake dir entry. CFFI will allow me to remove that. I have not got around to it yet. But rather than calling os.scandir directly, this is now has its own implementation of the underlying C function, its own wrapping of the underlying C function scandir. And the way CFFI works is that your second file, typically called yourthing_build.py, contains a small amount of C declarations. And the nice thing that CFFI does for you is that you don't need to worry about what goes here. The ... is filled in for us by CFFI. And again, here, we don't need to, our cross-platform implementation can be simpler because we don't need to know exactly what size of integer macOS or Linux exposes this type as. CFFI is able to fill that in for us. And these 37 lines are the sum total of the C that you need to write with CFFI. We can see this in action. This is the CFFI implementation. There is an existing virtual env here called v3. If we install this branch here, then we can use Python. Again, this is a different scanwalk that we are importing here. It's not the one that's on PyPI. This is the CFFI implementation of it. And we can see that because there is within it a second module, which is the C library that CFFI built and has exposed. And what this makes available to us is, for instance, this constant here, which is a C hash define, has been exposed and we are able to use it in Python. Or not. Wrong one. That should be .lib. Still no. What have I forgotten? Too many underscores. So that has been pulled from a C header somewhere in macOS. I don't need to know where. CFFI has done that for us. The result is that we can take our code from the pure Python implementation and use it without change. Still got the fake dir entry, but that is just because I haven't got round to removing it yet. CFFI allows us to. So that was the second attempt, CFFFI. It has the advantage that you are writing mostly Python code. You don't need to know much about C. And it's very few lines to get something working. And what you write will be compatible with CPython and with other implementations such as PyPy. The third attempt, which I'm experimenting with, uses a binding technology called Cython. Cython is a hybrid of C and Python. And in fact, you write a file. Wrong one. You write a file with a .pyx extension, and you are mixing normal Python, but also you are mixing imports of C functions. So py error occurred, py set from error number with file name object. These are part of the C API that CPython provides, the one from python.org. And these are the ones that are getting used by scanwalk.c. But here, we're using them in a more or less Python file. So we don't need to worry as much about the details of C. And this is probably the implementation that a future version of Scanwalk will use, because there are a few things that CFFI may currently make a bit difficult. That may be down to my knowledge of it. There may be other ways to do it in CFFI. Cython, in my experience, gives us the maximum flexibility of the raw C API in CPython, and the cross Python compatibility and conciseness of writing with CFFI, mostly Python. Cython was the sweet spot, at least for me. And if we try this, what has happened in the background is that Cython has taken our .pyx file, made a C file from it, which is this one. This one has been auto-generated for us by Cython. And then we can, just as before, different implementation, same API. We have our list of entries, and fake dir entry is gone. We're now presenting a uniform interface to the rest of the world. We've hidden the nasty stuff that we need to do to make that happen behind the Cython implementation. And we can proceed with the next release. So I think my time is up. Jason, would you like me to hand back?
Yeah, absolutely. And if anyone has any questions for Alex, by the way, thank you so much, Alex. It's really cool to see all the different ways that you can approach actually getting Python to work with C, work with other languages. So if anyone has any questions for Alex, please ask in the either in the live stream or in the Ask Speaker Discord channel. If you ask the next minute or two, I'll
I will
throw it to
be.
Alex.
I will be there to answer questions. I'll also be
Yes.
posting links to the package itself and the branches that have been the different experiments to see what worked for me best.
Now, I find it interesting that you didn't mention a lot about performance. Performance obviously is not one of the main goals here, but did you notice anything, because a lot of people think about, oh, let's work with C, it'll be better performance, and that's true in some regard. Did you notice any differences in performance, or is that literally just not a thought on the table for this project?
That was so I didn't have time to go into it, but one of the things I thought when I initially implemented this was that this would end up being a lot faster, because it turns out that the os.scander function in the Python library, in the Python standard library, doesn't use the C function scander. It uses a different thing from libc. And I thought by using scander that my package would be faster. That's not the case. There's a long thread about why that is on Twitter, and again, I'll post a link to that in the chat. As it stands, just because we're not building as many lists, scan walk under certain circumstances is about 10% faster. But frankly, that's neither here nor there.
I guess this just goes to show the value of the old adage that all performance is mythological until proven otherwise.
Indeed, yes.
Excellent. Just watching here, see if anybody else has any other questions. So I guess one other that I would have would be, at what point did you get the thought this should be a library? Because I think a lot of people feel a bit of hesitation because they're told, we have the saying, don't reinvent the wheel. And so people tend to, at least starting out, tend to be a little more hesitant to create libraries, and then they gain more confidence, think I can actually do this better. When did you decide that this was worth turning into a library?
So over the last couple of years, the interface of os.walk had niggled me slightly. I quite like using list comprehensions, and the nested nature of the tuples that os.walk returns makes that slightly messy. And there was os.scander sitting in the same module that has quite a nice library. Eventually, why not glue these two together? Experimented, quite like the result, and have released this. It is still very alpha. There is a lot more to making a package that you can just say to people, use this, it's better. But it is the way the world moves forward. So sometimes reinventing the wheel is a good thing.
Excellent, thank you. And then when this becomes as ubiquitous as Pathlib, we will say we knew you when.
If
I have confidence in you.
Thank you.
All right, thank you so much, Alex. So Alex will be hanging around the Discord. If anyone has any further questions, then he'll be posting those links there too as well.
Thank you very much.
Thank you. Right. Okay, so coming up next, we've got the real-time analytics stack by Mark Needham. And then a little bit later, I'm going to have to ask how to pronounce that name as well. I don't want to try and guess. I'm not good at guessing name pronunciations. Anyway, Python decorators from zero to hero. So we're going to learn more about decorators, and I'm going to learn how to pronounce the name, which I always enjoy. So cool. Make sure also that you enter the raffle for this book that giving away from No Starch Press. Link is right there. So if you have not already entered to win that, please do that. It's kind of fun to see what people would like to learn in Python. Someone said loops. Oh my gosh, I'm so new. Hey, you know what? Loops are cool. Loops are a different thing in Python than in other languages. So you may know loops in another language, you come to Python, then they're a whole other beast. Actually, that's a great thing to learn. I know experienced Python developers who haven't fully grasped that one. So that is a cool thing to learn. Absolutely. So I'm going to queue up this talk from Mark Needham. And yeah, so enjoy that. And I will see you on the flip side of that.
Hello, Pyjamas Conf. My name is Mark Needham. I'm a developer advocate at Startree, and in this presentation, we're going to learn about the real-time analytics stack. Let's start with the definition. So this is the definition of real-time analytics that Gartner gives. So it's the discipline that applies logic and maths to data to provide insights for making better decisions quickly. Let's see if we can figure out a definition that's a bit more practical. So we all know about events. So events are things that can happen. So it could be I searched for a hamburger that I want to buy. I visited a website. It's a metric from an IoT sensor. And these events happen, and we want to try and learn something from them. Like, what insight can we gain from knowing that an event happened? And then once we've got that insight, what action can we take as a result of figuring out that insight? And so that's what this whole talk is about. It's like, can we go from events to potentially some action? And the value of data decreases over time. So you can see here on the y-axis we've got value, and then on the x-axis we've got the time. And you can see over time it gets reduces in value. And the bit that we're interested in for this talk is the bit on that left-hand side, the real-time bit. And if we can do something with that data, then we can actually build some really cool data products. So who's interested in this data? So it could be analysts who are like running inside a company. It could be the managers of those analysts who are interested in knowing what's going on with the business. And it can actually be, we could loop that data all the way back to our users and build some cool data products for them. Let's just have a look at some examples of real-time analytics. So LinkedIn is a good one. So I'm sure most of you will have seen the Who Viewed Your Profile page. And this is a real-time, up-to-date view of how many people have viewed it. If you have the free version like me, you'll see a subset of those people. And then if you pay for it, I think you can see everybody who's seen it. And so this is a user-facing analytics application that is operating for 700 million users at sort of 10,000 queries per second. And then they have other ones as well. So you have the news feed, and the goal there is the action they want you to take is interact with this stuff. So they want to show you stuff that you're going to interact with. So they're going to keep a track, like what have you been interacting with in the past? What have you been liking? What have you been commenting on? And they're going to try and show you more stuff like that to try and get you engaged with the platform. And then the final one is they've got an internal application for recruiters called the talent pool report, where recruiters can kind of see across lots of different dimensions, like what is going on, like in real time with the job market, like what locations are people looking for jobs in, what types of jobs are available. And then we'll just do one more. So Uber Eats is another cool example. So this is the restaurant manager dashboard. So if a restaurant is operating on Uber Eats, they'll get a dashboard like this, so they can see hey, I've got these. This is my revenue that I'm making, and it compares it to the previous period. I can see the top selling items. I can see any feedback that I've got on the menu. And then most interestingly, in terms of action based metrics, we've got the missed orders and the incomplete orders. And so if we saw that those were happening, perhaps we could actually go and do something about it. Maybe we're going to get a coupon over to those people, or maybe we're going to call them up and say, hey, look, I know we've missed this order. We're going to sort it out. And so what I want to do in this first half of this talk is tell you what tools do we need to build these types of applications so that we can all be like LinkedIn or be like Uber Eats. And so I want to give you a map of the tools that that are available in this space. So this is a diagram showing all the different tools that we use as part of the real-time analytics stack. So we've got the event producers. They are moving data into the streaming platform. We've potentially got a stream processor operating on the data in the streaming platform. We've then got a serving layer sitting there afterwards. And then finally, we've got the front end that is serving the data to the users. And we're going to go through these one by one. So we'll start with the event producers. So where do events come from? So the first place is they could come from our existing infrastructure, so existing OLTP databases. We could use the change data capture pattern to capture the changes that are being made to our OLTP databases in MySQL or Postgres. We're using tools like Debezium to stream those messages into the streaming platform. And then another one could be event trackers. So like we're browsing on a website and they're capturing like what are we doing on the website, what pages have we visited, where have we looked at, like getting those kind of like views on. Hey, look, a lot of users are looking at this part of the screen, like that type of data. Like all that is events that event trackers might be streaming into a streaming platform. And then finally, it might just be a language SDK client. So perhaps you're capturing your own events and putting them into a streaming platform. So there's lots of different ways that we can get those events. Once we've got those events, we're then into the streaming platform itself. And the streaming platform ingests events from those sources in a scalable way and stores them durably. And it'll often be storing them in a topic. So like different type of events go in different topics. And typically it'll be based on some sort of distributed log file. Events are appended to the end, and then we can partition them, the log, across multiple servers so that we have durability and scalability. And so here's an example of what a log might look like for a single partition in a Kafka topic. So we've got lots of records. They're going from older to newer. In theory, we have an infinite log, but in practice, we're probably truncating that at some period in time. And the technology choices in this area, so there are lots of them, right? Kafka's probably the most well known. We've got Red Panda, we've got Ably, we've got Google PubSub. Pulsar is a newer one. There's lots of different tools that you can choose from that are being used to store these events. Right, next up, stream processors. So there are lots of energy around this one at the moment. So what is a stream processor doing? So generally the events are coming in to our event streaming platform, and then the stream processor might be operating on those events. And it could be taking data, most likely it's taking data from an input topic and then putting it into an output one. And it could be doing some joins while it's doing that. Perhaps it's creating a materialized view. It could be doing streaming ETL. There's lots of different things that it could be doing. And then there are kind of like, it could be passing it on to the serving layer, but there are actually sort of three types of things that can happen with the data. First one is maybe we're just building a streaming analytics application. So we could just build stuff on top of the stream processor itself. We don't necessarily have to pass it to the serving layer, although in this talk we are obviously going to be using the serving layer. And we could be doing stateful aggregations, window operations, materializing a stream and then feeding it onto somewhere else. We could be building an event-driven microservice. So perhaps we've got like an event-by-event processing app sitting on top of this. And then finally, we could be using it for streaming ETLs. We could be doing some joins, some filtering, some routing. Maybe we're doing some repartitioning of the data and then passing it on to someone else. And there are, again, lots of tools around here. So Kafka Streams, I guess, was one of the early ones, but there's now lots of different ones. There's Materialize, Quix, Bytewax, Faust, Memgraph is a graph-specific one, and there are lots of others as well. And then now we move on to the serving layer. So this is where the data's going to live before we serve it to our front-end application. And so this will be connected to the event streaming platform, and then it's possible that a stream processor might be operating on the data in the event streaming platform before it makes its way to the serving layer. Generally, there are some desired properties for the typically OLAP databases that are living in here, but there are other databases as well. We want the data to be fresh, so we need to get it from the streaming platform to the users as quickly as possible. So we need to be able to get it in there fast. And then once we're querying, we want OLTP type query speeds on this OLAP type data. And then we need to be able to operate at high throughput. So potentially lots of users doing queries, or maybe lots of dashboards doing lots of queries for each refresh of the dashboard. And then we generally want some sort of way to query the data that's in this database. So like doing some joins, some aggregations, some filtering on these large data sets. And the technology choices under the serving layer generally fall into two types. So we've got the key value stores and NoSQL databases. So that's your Redis, your Elasticsearch, your Mongos. And then over on the right hand side, we've got more recent additions. So these are kind of databases that are optimized for doing real-time querying. So we've got Apache Pinot, we've got Druid, ClickHouse, and Rockset. And now finally, we look at the front end. So this is the tooling which is going to be used by our users. And they could be internal users, they could be external. Like we don't differentiate between those. And it could be, if we have like some in-house expertise, perhaps we're going to build something ourselves. So I would, out of these tools, these are React, Vue, and Angular, and there are lots more. I've just picked a few to start with. I would lean towards React, but I appreciate there are people who like the other ones better. In the middle, we could be using a low-code framework. So perhaps we're using something like Dash or Streamlit, and then, or perhaps even we'll use a data visualization tool, so even less code. So Redash, Superset, or Metabase would be some tools in that area. Now we're going to have a look at a demo. So how can we actually put all these tools together? And we're going to be using the All About That Dough Pizza Shop demo app that I've been working on. So if you want to find that to follow along, you can get it from this QR code or this URL. And now we're going to move over to have a look at the demo. Okay, so all about that do have an existing architecture which we can see now. So they're getting orders. We've got an orders simulator, which is simulating like the people sending orders. We're putting those imaginary orders into the orders stream. And then we've also got some data in MySQL. So we've got a bunch of products and some users as well. Let's just have a quick look at the data that we've got before we do any real-time analytics. So we're going to connect to our MySQL container, and we'll write in our password, and then we'll just write a quick query against the pizzashop.users table. As we can see there, we get some users coming back. So I think we've got about 1,000 users in there, but those are just a few of them. And now if we do the same thing with the products, we can write a query against that table, and you can see there we go. We've got a bunch of products that we're going to be working with as well. If we now exit MySQL and let's now query our Kafka instance. So we're going to be doing this using the kcat CLI tool. So this is a tool for querying Kafka streams. And we're going to query it, get it to query, pass in the name, the location of the broker, the name of the topic, in this case orders, and we'll just tell it, give us all the messages. So you can see those now come flying through. There's loads and loads of orders coming through. So let's run that for a few seconds, and now we'll stop. So there we go. So that's where we are. That's where we're at. Now we're going to look at the new architecture that they want to evolve to. So we're going to, first of all, put the orders stream into Apache Pinot, and then we'll have a Streamlit app writing queries against Pinot and building like a dashboard around all the data. And so that will give us like the overview of the orders. And then the extension of that is that we're going to combine the orders with products. So we're going to write the products from MySQL into a product stream, which we'll be treating as a table in Kafka, or a K-table in Kafka streams. And then we'll join that together with the orders, having flattened the order items out into an enriched order item stream, and we'll also load that into Pinot. So we're going to have two sets of data in Pinot. So that's what we're going to try and do. So let's have a look at that. So first of all, we need to get the orders stream into Pinot. So let's get into VS Code, and we'll look at how we would go about creating a table in Pinot. So each table in Pinot comes with a schema. So let's open our schema file. And so what we can see here is we've got the description of the different fields that are going to be in our table. So we've got a bunch of dimensions, and Pinot uses like kind of the terminology of a data warehouse. We've got dimension fields, so we've got ID, user ID, status, and then we've got JSON string for items. And then we've got metrics. So these are generally numeric values. So we've got products ordered, we've got total quantity, we've got price. And then finally, we've got a timestamp. So every time you're loading data in from a stream, you need to have a timestamp associated with it. Now let's have a look at the table config that goes along with this schema. As we can see here, we've got to have the same names. The name of the table and the name of the schema need to be the same. We're specifying that it's a real-time table. So what that means is that data is going to be coming in from some sort of streaming platform. You can also have an offline table, and in that case, you'd be batch loading the data, and it won't expect that streaming config to be there. And you can actually have an offline and real-time table together, like with the same name, and query both the sets of data together if you want to. Now let's just scroll down a little bit. And so now we can see the streaming config. So in this case, Kafka, we've got to specify where the broker is. We need to specify the name of the topic. So in this case, orders. And then we're saying the type of ingestion is going to be low level. And what that means is that if you have multiple partitions, it's going to spin up multiple consumers on the Pinot side to get the data in. If we scroll down a little bit more, we can see that we've got the transformation functions. And so what these are for is if we've just got some small changes that we want to do to the data that's coming in from the stream that doesn't maybe warrant introducing a stream processor, we can just do those inside Pinot itself. And so in this case, the timestamp is not in the right format for what we need. We need like a very specific format. And so we're going to use this from date time function to get it into epoch milliseconds. We're going to do the same. And then we're also going to do pull out the total quantity. So there isn't actually a field called total quantity on our orders events, but it is hidden inside items. So we're going to use this JSON path function. So we're going to do a sum over all the quantities inside those items, and that's going to go into the total quantity field. And then we're going to do a similar thing for products ordered. So again, that field doesn't exist, but we can call the length function on the items and then pass it into a JSON path array, and that will give us all the products that have been ordered. And so now we're going to go to the Pinot UI and have a look at the data that we've ingested. So we're going to go to the query console, and we're going to query the orders table. So let's just write a query that gets back a few of the orders. And so we can see there are a few thousand in there already. So we're doing well so far. So far, so good. Right. So that's the first part of the infrastructure. The next part is we want to be able to join the orders with the products. So let's have a look at how to do that. So first thing is, remember we said we're going to load the products from MySQL into the products stream. So let's just use kcat to check that we've got something in the product stream. So we can run that, and you can see like we've got a bunch of products. It's actually entered the stream because there's not that many. It's only just under 100. Now let's have a look how we're going to join those products with the orders. So let's open Visual Studio Code again, and we're actually looking at we're going to look at part of a Quarkus app that uses Kafka streams to join the streams together. And every Quarkus app needs to have or Quarkus Kafka Streams app even needs to have a topology class. We're going to open our topology class, and at the top you can see the name, the topics are defined. So we've got the orders, we've got the products, and then we've got our new one. So that's enriched order items. And then just underneath there's some deserialization and serialization code. And obviously this is obviously a lot more complicated in Java than it would be in Python. So apologies for that. If we then go down a little bit, we can see that we are extracting the order items. So the items are actually inside an array or inside a list, inside the order, and we need to pull those out. So we're going to flat map those out. And we're going to put those into a new stream, and this time it's going to be keyed by product ID. So we need to make sure the key of the streams that we're joining together is the same, otherwise it won't be able to join them. So in this case, product ID is the key on this new order items stream, and then we're going to have the key on the products itself is also the product ID. And so if we scroll down a little bit, now we can join it with the products. And so once we've done that, so we join that on that key, we create our new event, and then we're going to put it into the enriched order item stream. And if we now move back to the console, we can use kcat to have a look at that at one of the items in that enriched order item stream. And so you can see there we've got like a bunch of data. We've got the timestamp, we've got the product is embedded in there with its ID and its name, we've got the order item itself, and then we've got some other metadata as well. Now we want to get that data into Pinot, so we're going to create an enriched order items table. So let's go back to Visual Studio Code, and again we've got a schema, a little bit similar to before. So we've got an order ID, we've got the product, we've got the fields, and we've got some metrics, we've got the price, and we've got the quantity. And then if we go over to the table config, very, very similar to the orders table config, but we've got the same broker, different topic, and there's not really any transformation functions that are all that interesting. And then now we're going to go over to our Pinot UI. Let's have a look at this new table. So we're going to query that one, order items enriched. Let's refresh it a couple of times so you can see like more and more order items are coming in. So that's cool. It's all working well. The simulator is working well. And how about let's write a new query. So we're going to write a query that finds the product categories, and then we're going to find the top product categories that have orders in the last 5 minutes. So we're going to do a filtering clause there. And if we run that, we can see side orders and vegetarian pizzas are the most popular category of items that people are ordering at the moment. So that's cool. So this is quite a nice UI for doing ad hoc queries, but it's not like great for giving it to an end user if they don't have familiarity with SQL, or they just want to see, like, just show me the chart. Like, I want to see what's going on. I don't want to have to write the query myself. And so that's where Streamlit comes in. So Streamlit is a Python library for building data applications. And so it's often machine learning applications, but I find it's really good for this type of thing as well. And so we can integrate it with pretty much all the other tools in the Python ecosystem. So in our example, we're going to be integrating it with the Plotly charting library and the Pinot Python client. So let's open it up. So let's get that open in our browser. And so what we can see on the top, we can see the orders and the revenue and the average order value over the last 1 minute. And so you can see it's refreshing every 5 seconds. Let's change that. Let's change it to capture things that have happened over the last 10 minutes. So you can see now we've got a much bigger range. And we can even adjust the refresh rate. So we could get it down to every second if we wanted to. If we scroll down a little bit, we can see the popular items and the categories. So you can see again that we've got the side orders and the vegetarian pizzas. And if we go right down to the bottom, we've got the stream of all the orders coming in. So this is like all the things that are just happening right now. Let's just conclude it with the demo by having a quick look at the Streamlit code that is building this dashboard. So let's go into our Visual Studio Code again. And you can see we've got at the top, we're connecting to Pinot. So we've got like our connection string. Then if we scroll down a little bit, we've got the auto refresh code. So that's what's like causing it to loop back to the beginning to go again. And then at the bottom, we make a call to the refresh. And then we're doing some aggregation in the middle to filter for the headline numbers. And that's how those top numbers are being populated. And then finally, we're putting them into the what Streamlit calls metrics. And so, yeah, that's the end of the demo. So hopefully you enjoyed that. And now we'll conclude the talk. I'd like to thank you for listening to my talk, or listening and watching to my talk. If you want to find me, this is where I am. So I'm on YouTube, Learn Data with Mark, or Mark H. Needham on Twitter. If you want to learn more about building these type of applications, we've got a bunch of materials at dev.startree.ai. And I am co-authoring a book with Dunith Danushka, who is the creator of the modern streaming stack. So we're writing a book called Building Real-Time Analytics Systems, which will hopefully be ready in early 2023, but it's already on the early access program on Safari if you have access to that. So thank you again and enjoy the rest of your conference.
Hello again. I'm Charles. I'm Jason's cousin. I'm filling in while he's getting coffee, so I'm taking a break from my quadratic equations. I'm just here to tell you that we're going to take a few minute break, and then we're going to come back for some more awesome Python talks. So, yeah, this is great. And I'm going to go do some more quadratics, because that's what I do. I wish you could have seen what was going on back there because the music we got dancing, so there was a lot of dancing going on in the backstage, which was awesome. So I wish that could have been live, but it wasn't, and some people will be grateful for that because you don't want to see me dance. You really don't. Awesome. So welcome back to Pyjamas, the coziest Python conference on the planet. And coming up next, we got Python decorators from 0 to hero. And then hang tight because after that we got functional meets object-oriented programming. I don't know why they keep letting this guy back in. I'm going to let you know now. This guy is weird. So, yeah. Anyway, but it's going to be an interesting talk. So, if anybody asked, I don't know him. Yeah. Anyway, so we got that and plenty of other awesome Python talks coming up. If you have not already entered the raffle for this book, Dead Simple Python, giveaway from No Starch Press. Well, giveaway from us, but published by No Starch Press. Check that out. Sign up for that. Been reading some of these things here about what people would like to learn always wanted to understand better in Python. And I've seen a few things about asynchronous programming. That is an interesting topic. Fun fact, the difference between asynchronous programming and threading is actually fairly technical. So if you understand threading already, the way threads work, then asynchronous is just, it's letting your code handle it instead of letting the operating system handle it. That's the high-level summary. The low-level summary is very deep and complicated and kind of interesting to get into. So, but yeah, asynchrony can be a blast. And actually, that book does cover it. Speaking of asynchronous, by the way, async database, SQL and Python, that's been rescheduled. So I haven't mentioned that in a while, but yep, that'll be coming up at 2100 UTC. So if you want to check that out, all you async fans, that's been rescheduled. Make sure you check that out. And of course, stop by our Discord. Plenty of conversation, fun things going on over there. You can chat with the what's the word I'm looking for? Gosh, suddenly I forgot. You can chat with the speakers. That's what they're called. They're called speakers. This whole time, I should mention that I'm giving this with a cold. So my head's a little bit fuzzy. So if I seem a little bit more scattered than usual, that is why. Some of you have not noticed the difference. So yeah, rather than hearing me blather this whole time, I'm going to go ahead and bring in, you're going to have to help me pronounce your name because I want to do it right. I'm not going to make it up.
That's okay. My name is Vinicius. My complete name, Vinicius Gubiani Ferreira. But I don't mind seeing people pronouncing my name in many different ways, and I accept them all.
Yeah, Vinicius. Vinicius.
Yeah, Vinicius.
Yes, I got it.
Right.
See, I have one of those names that everyone can pronounce usually, but I like to mess with baristas at Starbucks, and I tell them it's spelled with 3 Q's and 2 Z's. It's yeah, it's fun to throw people off. So yeah, well, we're gonna wait just a minute, just in case people are coming in because they want to see your talk and they're all excited. But looking at your bio though, while we are waiting for people to trickle in here, so you like reading other people's code?
Yes, I do. I love to code review other people code, mostly in Python. Well, and quite often when I see JavaScript code, I feel like running away from them, not doing any code review of JavaScript code, and just messing around with other languages, other code in pull requests. I love to see code. Makes us learn a lot and help other people.
Nice. Have you heard of this thing called code reading clubs? Billy and Armand's founded these about a year or two ago.
I think not. At least I don't remember it right now.
Okay, you might enjoy this then. So if anyone's wondering what I'm talking about, codereading.club. Programming professor Philion Harmans, the author of The Programmer's Brain, started this whole thing where basically you get together once a month with this group, or you can start your own once you know how it works. So you get together once a month and you look at a piece of code that's been pulled off of GitHub somewhere. You don't know what language, you don't know what the source is. You're looking at it together using different reading strategies, and it's a really interesting way of looking at code. So when I saw you mention code reading, I thought, I may like that.
Interesting. I'll check it out.
Yeah, absolutely. Yeah, so another minute to go. So what's in the, I'll ask this then, what's in the mug? Like, if you're going to get a hot beverage, what would you be going for?
Well, it's not a mug, it's a cup. I have water over here. I'm not sure if you can actually see it, but
it becomes invisible.
My guess is you're probably having some coffee. I'm not know. Right now, what time is it over there in UTC? Is 5 p.m., right? For me, it's 3:30 p.m.
Yeah. Here it's here in central US, it is 12:30. So I've got my coffee. And I'm sipping on that while I'm watching all these talks, which is always fun. So yeah, awesome. I'm gonna go ahead and we got about 30 seconds to go, so I might as well get everything up. And you'll be anyone who has any questions. I'm just going to let everyone know now. If anyone has any questions during this talk, go ahead and stick it in the live chat or put it in the ask speaker. You don't have to wait till the end. Go ahead and stick it in there. And then at the end, if we got some time, I'll ask a couple of those at the end of your talk here.
Yeah, that's okay. I think we'll probably have some minutes if anybody has questions at the end, but I think that's from my timing. I think we'll probably have questions. Okay.
Awesome. All right. Well, here is your screen share, and take it.
Great. Thanks. Let me just grab my notes. All right. So first of all, thank you so much for the opportunity to be speaking here at the conference. And we're talking about Python decorators from zero to hero. And let's go. For anybody who never heard about me before, as I mentioned a couple of minutes earlier, my name is Vinicius Gubiani Ferreira. I'm currently working as a QA team lead at Asion Technologies for a couple of months now, about 6-7 months, something like that. Asion Technologies is a Brazilian edge company. And prior to that, I've been working with Asion for 3.5 years as a senior Python backend developer. And like most people that code and love quality, I think this picture of a guy cutting grass with scissors describes pretty much it all. I feel annoyed when something's out of place, can be improved, like there's a little shed in the edge that you should probably take it off to improve it in any way. I'm really annoying due to lack of quality. I always strive to do the best as possible. Every now and then I work as an open source contributor. I think pretty much the most interesting project that I worked on to consider myself an open source developer was the Python documentation for Brazilian Portuguese. It was quite awesome to engage with people across the country and with the same goal and trying to make it easy for others to learn. And among my hobbies, I like craft beer. My favorite one is Vice, and riding a bicycle around the park. I don't have a bike myself. I just use a rental bike that is available in my town. And that's about it about me. Let's talk about Python. And here's our schedule, our agenda for today. We're going to discuss code, mostly code. And it might not be easy for everyone, but hopefully I was able to make it easier enough so that everybody can understand and follow along until the end of this presentation. And we're going to discuss in this order about nested functions in Python, then talk about decorators, their extended version, then their short synthetic sugar version, the limits of what we do and we cannot do about decorators, and the real case of mine, which motivating me into doing this presentation. And right, let's go. So nested functions, what exactly are they? And I'm so glad that you asked. In Python, this is pretty much for anybody who is starting today. This is the hello world of Python. Every language has their own hello words in different syntax, different formats. Hello world in Python goes a bit something like this. We have a specific reserved keyword, which is the def for setting functions. And after we type def, we just set a name, use parentheses, double quotes, and do whatever we feel like inside a function, which in this case, we're just doing the usual hello world. That's about it. We define our function. And then after we just call it, type the name again and use parentheses, it runs printing just a simple hello world. Voila, nothing new, working just like as expected. And this is the hello world where we start discussing about decorators. Nested functions are pretty much just a function defined inside of another function. When I type this into my Python interpreter, we can see that it didn't execute it, it just defined the function itself, which in our example is named parent. And basically we have a function that executes a few instructions and just shows something on the screen, just like the hello world previously. And we have the definition of other two functions, which is first child and second child. They also print some string to the screen. And notice that we have the opposite order. We're calling first, second child, and just first child, just so we're making sure that we can actually notice, just not be a coincidence that first child was defined first, and then it's going to be called first. And when we run this code, it runs very in a linear, predictable way. It just calls the first print, then define the inner functions, and call the second child, and then the first child. And some people might be wondering, okay, but how exactly is this useful? How this relates to decorators? And we'll get into that in a couple more minutes. Just hang on tight. And a brief intro about nested functions. I honestly think that using nested functions is a bad idea, at least in my experience of codes that I've seen before. The only good reason that I think it's actually good to use nested functions is probably just to define Python decorators. And we'll get in later slides how bad can it get to set nested functions one inside the other. So whenever possible, please avoid doing nested functions. So let's talk about decorators. The decorators, Python decorators, the simplest version, which is at least the long version, can be defined into something like this. We have a function we have a decorator function, and it boils down to passing a function for another function as a parameter. And some people might be thinking, wait, is that even possible? And turns out it is, but there is more important parts in that. The important part is we're passing the function, but we're not actually running any of these functions, at least not right now. We're postponing them when they are going to be executed exactly. So in this example, we have a function passed as a parameter, is named func, and we don't know exactly what this func is or what it's doing. We just know that it's going to be called. So this is kind of a mind-blowing. Twist your head around it to understand what is this function going to do. And we have to accept that. I don't know. It's going to do something later. I'll think about that later. And we have another function that's defined as say we. It just prints we to the screen. And we're going to use it in our decorator. So we have after defining our two functions, we're going to call the first function as a decorator, and the second one is going to be considered a decorated function by the decorator itself. So what we're doing on the next line, on line 11, we're actually passing the function to the decorator function and reassigning to the function itself. It seems different, at least for people that are new to Python or are not actually used to using decorators like this way. So once again, our function did not execute it, as I mentioned before. And if we decide to check the say we function by just invoking it and not actually explicitly executing it, we're going to see something at least odd, let's say. The Python interpreter is going to tell us, hey, this say we function, I have a my decorator function, which is a wrapper around the say we function. This is kind of odd, at least to say, not anything different, but it proves that our function is now decorated with the my decorator that we just defined. And if we run this function by calling it with the parentheses, then we can confirm that both the decorator and the decorator function actually executed. We can see that we have a before part, which is this something is happening before, And we have the function, say we, that works like a middle part. And we have something that is executed after that function. And with decorators, this is pretty much the basic idea. We have something that we can execute before. We have our decorated function, and then we can execute something after. And we're not obliged to do the before part and neither the after part. From my experience, most of the decorators that I've worked will usually either go for the before part or the after. It can happen that we actually use both, but it's not that frequent. It's not that often. And as I mentioned before, that func that we are passing as a parameter, it is a decorated function. This we that is being shown on the screen. So some people might also be wondering what exactly is a decorator purpose. And the purpose is to modify a code, an existing code, for example, that we're not actually allowed to change it, but we're not actually changing the code per se. We're adding value, we're executing something before the code that we're not allowed to change it. Or on the other way around, we can create a decorator and execute something quickly to our existing functions. Let's say we have a ready decorator that somebody else built, and we just use it into our code. That's pretty much the main purpose of decorator, like changing your code, but without actually changing your code by doing something before it. And we could actually add several decorators on the same function, like stack picking one on top of each other, but we have to do that same syntax, like a function that reassigns to it, and then grab that new assignment and pass to another decorator and to another decorator. And that's not going to make the code very good or easy to understand, very easy to make maintenance later. So to solve that, the Python community, I'm not exactly sure when, decided to create a new syntax for decorators, which is more syntactic sugar. So the short version for decorator, not the long version, goes a bit something like this. We have our same decorator from lines 1 to 6 that we've seen before. Nothing new here, nothing changed. But our decorated functions from lines 9 to 10 now have a new syntax before it. Is that symbol at my decorator? We're just using a specific syntax, like I mentioned before, a syntactic sugar, easier way to call the decorator. And if we check our decorated function, the say we, once again, we can say that the Python interpreter say, hey, I have a method called myDecorator working as a wrapper before this function you're telling me say we. And if we run it, we get the same result as before. Thank God for that. Otherwise, I'll be passing shame over here live. And we can see that it once again executed something before, then our function, and something after. And from now on, things that we got the basic of decorators, things starts to get interesting. And you might be thinking, how and why everywhere I can use decorators? And the answer for that question is you can use your own creativity to use it whatever you like. For example, there's a specific code that I would like to execute, but I should only execute it if the user actually have permission to do that action. So you can probably add a specific decorator to check if the user actually have permissions, if the token he's supplying on a request actually grants him permission to do that. You can also, for example, check if he purchased that product where he's trying to interact with that request. If that actually is available, let's say you're doing some A/B testing and the person that is trying to access that endpoint or that feature is actually on the A group and not on the B group, then you can also use decorators for that. What else? You can, after someone uses a specific method, you can write it to a log file and be stored on a specific log system. So the possibilities go just as your creativity allow you to. And I brought some examples over here to that I pick around on the internet. And here's a quick example for that. We wrote a new decorator, and we're not actually doing like a before and an after part. Over here, we're just using the function that is passed as a parameter, and we're running it twice. We can say from the method name, it says do twice. And once again, I use the very helpful function say we, and I decorated that function with the decorator do twice. And you might be wondering, what exactly does that method do? And turns out, for probably surprise for no one, it just runs the method twice. We can see that it prints to the screen the we just twice. Print it once, print it twice, and ends the execution. Okay, so what else can we do? Let's say you have systems that perform mathematical operations like stock market or calculator, something like that. You can, for example, create any specific mathematical operations. For example, you can return a number and elevate it to the power of 2. Then this simple decorator just run a function, which brings a numerical result, and run that same function again, multiply it, and return it. And that's another example, but you could do it for pretty much any numerical operation that you'd like. And to wrap this presentation, I'd like to discuss a case of mine that motivated me into doing the presentation itself. And as I mentioned earlier, I'm working as a quality assurance engineer. And I skipped the slide. Go. We have a specific test for application, which is responsible, a class that is responsible for managing this menu on the top left side of the corner, this hamburger menu. And you can see that it has a few sub-menus. And throughout our code in this class, we needed to know which screen we're actually right now after clicking into this menu, because every now and then we're clicking once again in the menu and reloading the screen, causing some error on the tests. And I started to notice that some code was starting to repeat itself. And that's a case where decorators come in very handy to remove this repetition of code. And this is the decorated function that motivated this presentation. You can see that is a bit more complex. It has actually 3 layers of nested functions instead of 2. And but that's not a big of a deal. It's still a Python decorator. The only difference is that this decorator actually accepts parameters. The previous one did not. And in the internet, you might find this referred to as a decorator factory. I didn't know that name, so you might stumble into that. And as we can see, I'm going to skip to the next slide. Hang on. This is the actual code, one of the methods that was starting to repeat itself inside the class. And the parts marked in red are the code that was moved to inside the decorator. And we can see that we have the before part, the part in white. It's the part that is going to be passed to the decorator itself. It's that mysterious function where we don't know what is going to be executed inside. And the after, as I mentioned before, we're just saving the state of which page we are right now. And as I mentioned earlier, the decorator, it's receiving a parameter. And we're going to see in a couple of minutes, this parameter is just to let the class know which page I'm viewing right now, which one was the last menu that I clicked on. And as I mentioned before, this code was starting to repeat itself. The only part that was actually changing among the different methods is this white part of code that is not marked in menu color. And let's skip ahead to discuss about the decorator. And if you look at our decorator, we can see that the decorator have a name, which is menu alias, that is being used on top of here just before the method that is being decorated. And we also have two functions, which are pretty much wrappers to what's going to actually be executed. Then we have function arguments. In this case is the class that represents the menu with several methods. And then we're actually checking on lines 11 to 13 if we are exactly at the same page that we just clicked. And if that's the case, then we're going to do nothing. We're just let the user know, hey, you're already on the page that you want to go, so I'm ignoring you for now. And if it's not, then perform the click on the menu itself, sleep for 1 second to let the screen load, then execute that method that's passed as a parameter, the decorator function. And on line 19, we just save where exactly we are right now. So this is complex. I admit it's quite complex for anybody who's not used to writing decorators or even new to Python. Takes a while to sink in, but don't worry. This gets easier if you get your hands dirty by writing decorators. And some people might be wondering, could we break this down into two methods to call just the before method and after method? Yes, we can, but we had the opportunity to write a decorator, then we decided to go for it. And one thing that I forgot to mention, decorator is a design pattern. A design pattern is usually a convergency methodology for a common problem, like different people that don't have any contact at all came up to the same conclusion by solving the same problem with almost the same conclusion. So this ends up being published as articles and becomes a designed pattern. So most common uses for decorator I've seen, as I mentioned before, is like checking for permissions, checking for tokens, like removing code duplication, the dry, don't repeat yourself. And don't worry about getting to know all of this at once, because as I mentioned, this is complex. And on a daily basis, you're probably not going to write decorators a lot on your daily basis. You're mostly going to be using decorators, like somebody pre-built this decorator, so I'm just going to grab it and use it. But when you have the chance to write a decorator yourself, I sure hope you came back for this talk to get the basics of it and know what's a decorator, how it works, how I write this code, and I sure hope it helped you. Well, that was about it that I had prepared. Once again, thank you so much for the opportunity for being here at the conference. And I hope you guys enjoy it and stick around until the end. And if you have any questions or feedback, whether it's good or not, I'm available for contacting to any of these means. And I think we have a couple of minutes right now for questions. And once again, thank you. If you have any questions, I think that's a good time.
Yeah, absolutely. So if anyone has any questions, Vinicius, put them in the live chat here or in the Ask Speaker room. And if you don't get it in time and you think later, oh, I had a question, message them in the Ask Speaker room back to back, and Discord's awesome. Actually, while we're waiting to see if anyone has any other questions, I'm kind of curious. When did you first discover decorators, like in Python? When was that light bulb moment for you?
Using decorators mostly on my current job, I started seeing code, and I remember one of the first time I saw a Python functions, because I never seen in Python the symbol, the @ symbol, for in the middle of the code. I've seen it on top of a few functions, and once I looked at, I've seen a function with 3 of those, and I started to wonder, okay, what's going on over here? This can't be a coincidence. This is not just to make the code prettier. So I had to dig it up a bit, and then I saw a specific code a bit spread into the repository itself, but I quite didn't grasp how did it connect to the code, because the syntax sugar of the decorators really feels like magic. You don't understand exactly how is this connecting exactly. But when you start to see, oh, this function is actually calling that function, then it makes sense. Okay, this is just something of the inner workings of Python itself.
Yeah, exactly. I think the part that I tripped over the most when I started learning decorators was the closure pattern. Like, decorators themselves weren't all that confusing, but closure, the first time you see it, is like, what am I looking at here?
Yeah.
Do you know of any other languages that use the decorator pattern?
Sorry, can you get that again?
Do you know of any other languages that use the decorator pattern, or is that more of a Python thing?
From talking to buddies at the company and outside the company, I've seen that decorators are mostly used in web development, in Python, and I think Spring and Spring Boot with Java also work with decorators a lot. There's a common joke that I've seen from a couple of friends. They say that Spring Boot is like decorator-oriented programming. Like, you can do small methods and stack like 6, 7, 10 decorators on top of each other to do pretty much you'd like. And your method is actually smaller than the stack of decorators. For that, I'm using.
Oh my gosh. Yeah, I can imagine that would get overwhelming for a while. So it's kind of like the object-oriented pattern of extend rather than rewrite, but it's being applied to functions instead.
Yeah.
Interesting that it shows up in a very object-oriented language like Java.
Yeah, it's also a good questions for interview jobs, because if you want to ask if a person has some experience with Python, you just hit it with a question like, "Tell me about Python decorators," and then you see so many beautiful and creative answers. Like, if the people, you can tell if the people is making them up or they're like trying to express with their own words. It's crazy, but it's nice to see how people understand or think they understand about decorators or design patterns per se.
Exactly. Well, the name kind of throws you off too a little bit. Like, is this just decoration? Is this real code, or is this just decoration?
It's not actually there just to be pretty. It's probably doing something.
Absolutely. It's not just wall paint. Yeah.
Yeah, exactly.
Well, thank you, Vinicius. That was great explanation of decorators. That's the actually explanation I wish I had had several years ago when I was stumbling into it for the first time. So.
Yeah, it looks like witchcraft, but if you stop and read it for a while, then you get to know what's going on, and it feels less witchcraft.
Yeah, absolutely. Like most of Python in a nutshell. Thank you very much. And if anyone has any questions for Vinicius, please post it in Discord. And thank you very much.
Thank you.
All right. So, yeah, coming up in just a moment, actually, is functional object-oriented programming, or Immutable and Loving It. And then after that is beating Tim Sort at merging. That should be interesting because Tim Sort's one of the fastest search algorithms. So beating it at merging, that's going to be an interesting talk. I secretly really like sorting algorithms and searching algorithms and all the stuff that goes into that. So that's interesting. And if you have not already entered the raffle for the book Did Simple Python from No Starch Press, please do that there. So we're giving away a free copy to someone, and we've been asking people what is one thing that they want to understand better in Python. And yeah, there's some interesting stuff in here. Someone says types in Python, is it as simple as it seems? Yes and no. Yeah, types are really easy in Python until they aren't. So that book actually goes into some more detail on that, but yeah, it's a different way. Like most things with Python, it's a different way of thinking. So if you come from another language and you're picking up Python, um, understanding Python for itself instead of through the lens of another language is one of those big jumps. So yeah, we're right up on this. So our next speaker is me, actually. Surprise, surprise. So I'm going to see if I can get my screen share up here, because in the desperation to get everything else set up, I haven't tested this out yet. So we're about to find out if this works. Yeah, so here's to experimentation. Yes, awesome. So y'all can see that there. All right, so functional and object-oriented programming, diametrically opposed concepts, right? I mean, we have functional languages like Haskell and Clojure and Elixir. Then we have object-oriented languages like Java and C# and C++. So which one's Python? Well, Python, everything is an object, so it must be object-oriented, right? But then you look and you see things like closures and lambdas and immutable strings, and then you begin to wonder, maybe it's functional. When in actual fact, Python is both. It can do both paradigms and many others besides. But the way it's implemented these paradigms allows you to combine the best of both functional and object-oriented programming to create some pretty resilient code. And that's what we're going to be talking about for the next 20 minutes or so. So if somehow you have missed it, my name is Jason C. McDonald. I'm also known across the internet as CodeMouse92. And that book we've been hyping up the whole time here is actually mine. So recently published from No Starch Press. So if you're looking for an explanation of the entire core language of Python, whole thing, without being dragged by your teeth through the basics of coding 101 all over again, this is the book for you. And I go through, I guide you through the whole core language and the whys and the wherefores of idiomatic practice. Everything I'm going to talk about in this talk is in the book. So if you want more detail, definitely check that out. Okay, so object-oriented programming, what is that? Well, the big benefit of object-oriented programming, the reason why it's stuck around for so long, is encapsulation. It's a great way of organizing related data with the, with the methods that modify that data. And you don't have to understand how it's actually doing it inside the object. It's just you put in some data, you get out some data. Pretty straightforward. Objects and classes are really reusable. You can instantiate multiple objects. You can reuse bits of code from different classes using inheritance patterns. So you get a lot of dry, don't repeat yourself type patterns. And when you're writing good classes, you should bear in mind the single responsibility principle, or the S in that solid acronym everyone throws around, which is that one object or one class should have one clear responsibility. But there are some downsides to object-oriented programming. Common complaints include that it's unpredictable. You don't necessarily know when or how these objects are interacting with each other. And it can be hard to even see where data comes from, where it goes to, because everything is made up of these black boxes that you can't see inside of. It can be very difficult to start figuring out where a change occurs to some piece of data. That's when black box starts fighting against you. We call it ravioli code. Generally, once you get inheritance involved, you just get this big hairy mess. You inherit the multiple inheritance, and it gets really complicated if you're not very careful. And this has led a lot of people to just demonize object-oriented programming as a horrible thing. The answer, they say, is found in functional programming. So functional programming brings with it this concept of purity. No side effects. You pass in a value to your function, and you know that that value itself is not going to change. Function is going to return something else. It's stateless, so a function is not going to depend on any external state. It's only going to care about the data that was passed to it. It is repeatable, so you pass in the same value to the function, you should get the same output every single time, which is great for testing, by the way. Functional programming is very, very testable. It's isolated. One function doesn't really care how the rest of the code is implemented, as long as the functions it relies on have not changed what they're returning, then it's just going to keep on working no matter where in the code it lives. Functions are reusable, obviously, and you can apply the single responsibility principle here too. One function has one responsibility. Names are a great hint, by the way, of whether or not you're violating this. If you need the word "and" anywhere in your function name, you got a problem. So this makes it sound like functional programming is the answer to the life, universe, and everything. But there are some downsides here too. Performance, immutability, meaning never modifying an object, is really a bad thing when you're dealing with very large bits of data, like a NumPy array, a pandas data frame, a very large image. Making copies of that is expensive. And so it's really impractical for, say, data science. It's not great for GUI, because GUI is very stateful. You have all of these bits of state that have to go somewhere. It can be hard to think about structuring functional programming because you have to figure out how you want to organize your functions. But more importantly, where's that state going? When you have some piece of data, you need to keep track of where do you put it? Where does it come from? You might be tracing your way through a long chain of functions, and that can get rather obnoxious after a while, especially when you have multiple pieces of related state, which is when it becomes a problem. So this isn't necessarily the answer to everything, but functional programming does solve a lot of problems. The biggest advantage to it is purity. It just makes your code a lot easier to reason about, a lot easier to test and verify. Object-oriented programming brings structure. So a rational, kind of organic way of laying out your data that just makes inherent sense. So it's not really the demon that some people like to think it is. So we're going to talk about how to combine these two together. So to understand how object-oriented and functional can work, we have to remember that objects encapsulate data. No, strike that. We're talking functional. So objects encapsulate state. Multiple pieces of related data that make up state can be encapsulated together into an object. Now, there's two ways that we can approach this. One is predictable mutability. We're wanting that predictability of functional programming, so we have to respect purity. So there's some patterns we can use to do that. Or we can use more immutable objects, which is a thing in Python that a lot of people do not realize is possible. We're going to talk about both of those. We're going to start with predictable mutability. So with functions, functions always have to be pure, meaning they don't modify their parameters. There's no side effects. If I pass A to a function, A should not change. One exception to this is that a method may mutate self. A method belongs to a class, and so a method can mutate self. This actually makes sense visually because you see that A is not inside the parentheses on that second line there, it's in front of it. So that A dot and then whatever can start becoming syntactic sugar for A's getting modified. It's the same as reassigning, like we see here, B equals F of B. B is obviously being mutated. It's being changed in this case. So we can consider these to be somewhat equivalent bits of syntax. You can use a lot more properties too. I really love properties because this first one, this is just a getter that is disguised as an attribute on an object. Calling a.x Obviously, it's not going to change anything. It shouldn't change anything. So there's no surprise there. We're just accessing something. Whereas the setter through a property, a.x equals 6, that is changing x, or a, well, changing both. You would expect that because you see the assignment. So it becomes a lot easier to spot when you're changing things. Downside to properties, you can't really pass multiple parameters to it. But you can usually get around that problem, and in most cases, you just have to think about your code a little different. Optionally, you can set a rule for yourself that your methods have to mutate self. That is, that you come to expect that if you're going to call a method, that it is going to mutate the object you're calling it on. So if you don't want to mutate A in this case, pass it to another function or pass it to a class method. This way, you can see it's inside the parentheses, and that's kind of a guarantee it's not going to get changed. In case you're wondering if this works, I actually did apply this in a production grade data science project involving huge, huge images. And it does work. There's a lot of state involved in that project, and this pattern really did work. So when you're following those rules, then you can add one other rule to your mindset with functional, and that is don't call methods on arguments. If I'm taking X as an argument, I can access a property, I can pass it to another function, but I should not call a method because that could be mutating. So I don't do that. The exception, again, is on self. We can always mutate self. That's fine. You also want to avoid assigning, especially mutables, because, think about it, you've probably seen this before. If you pass a list to a function and then you append to that list, you modify the list you passed in, which is bad. So as a rule, just don't reassign, because what's happening here, in case you aren't familiar, is you're creating an alias. A and X now point to the same object in memory because X is a list and it's mutable. It can be changed. So that could be a problem, because now if I mutate A, I'm mutating X. Not good. But if we pass it to something else like copy, that's returning a copy of X, and then I don't have to worry about that so much. Now, what about statelessness? We're actually okay here. Methods do not rely on external state. They're using the state being passed in on their arguments because self is an argument. So we don't actually have to create global state. We can continue to avoid that. Possible exception may be if you're working with GUIs, you may have to fudge the rules a little bit there, because doing GUIs without global state is a little hard. Not impossible, but difficult. And by the way, if you're wondering if this is violating functional at all, we already excuse closures on this point. You can write a function that returns another function that is closing over the value that was passed to that outer function. That's okay. We've been doing that in functional. The closure language is literally the name for this pattern, and that's functional. So that's okay. It's all right if a function is containing some state that was explicitly passed to it. All right, so before we go further, just to hammer this point home, functions do something. They perform an action, whereas objects are something. The talk I gave a couple of years ago called "You're Doing Classes Wrong and So Is Everyone Else," I talked about how classes should be defined by their constituent data. Never create a class on the basis of what it does. Create it on the basis of what it is. So let functions be your verbs and objects be your nouns, as it were. So object-oriented programming brings with it organization. Objects can encapsulate state, which could consist of multiple values potentially. For example, I'm loading an image from a path. That image object might actually contain the loaded image itself as well as the path to that object. I can then mutate that state internal to the image object. For example, removing the alpha channel from the image. I could also make conclusions about that state. I could expose a property called dimensions, and that returns the dimensions of the image. So there's no need to, So all of this can go inside of the object, and there's no need to understand how it's doing it, as long as we understand what functionality is being exposed. So that's where encapsulation comes in handy. Mutability, how do we take advantage of this when we're not able to modify on our parameters? Well, we can allow a function to own a heavy object as long as it's acquiring that object. So in this case, we're passing path and rule to f, and we can use those, but we're not modifying either one. F, however, is calling another function that's getting this heavy object. Maybe it's creating it, maybe it's just getting it from another function, but it is owning that object. Since it owns it, it can use mutability. So we can mutate on heavy, do whatever we want with it. And then we could return a lightweight result. That would be fine. Or we could return the heavy object and never mutate it again. Or actually, correction I was going to make for the slide and I didn't, is if I'm calling f from inside of another function, as long as that function is owning that object, it's the one actually calling it, then I can mutate it all I want to, because it's not being passed as an argument. So see, you can actually work with this in the functional patterns. It just requires a slight shift in your architectural thinking. And again, I've actually used this pattern in production. It is possible to do. So the benefits of this are threefold. Functional programming gives us nice testability, purity, less surprises. Objects allow us to organize code, which is great, organic organization kind of patterns. And then mutability gives us good performance when we're dealing with large, complex data. So that's all great for predictable mutability. What about immutability? Python's got some immutability, like integers and strings. You can't mutate those objects. They just are what they are. Once they've been defined, they can't be changed. And this really blows past a lot of these problems, because you can't modify something that you can't modify. It's pretty straightforward. So if we can write some classes of our own that we cannot modify, then that's going to make our code a lot more resilient, because now we're getting error messages instead of just bugs. So here's the point at which I'm actually going to program this instead of throwing some more slides at you. So I am going to bring up my editor. Bear with me for a second, because I have to switch my screen share. And that should be this. There we go. PyCharm. Good times. Ignore that first line. I just have that saved because I'm too lazy to type it out again. So let's talk about a class. Let's just start by creating a class called RGB color. Let's do it the traditional way first. So in our initializer, we want 3 values: red, green, and blue. These are meant to be integers, but I'm not going to take the time to put in the hints right now. Basic initializer. And then let's do dunder string, just so we can see this represented as a string, specifically as a hex code. I do love my F strings. So if you are curious what this is, look up the formatting codes for F strings. A lot of cool things you can do with them. So these are 2-digit hexadecimal numbers. Okay, so let's create color. Let's just go with white, because that one's easy enough. I can print that out, and let's do black as well. So there's some easy colors that we don't have to memorize the codes for. Let's print this out here. So let's run this, and you see it prints out white is FFFFFF, black is 00000. That works. Okay, but there's a couple of problems here. I'm gonna hide this one for a minute here. There's a couple of problems, because I can modify this after the fact. Let's see. Let's say I want to change red to 42. And I'm going to add a random attribute here So let's change this to 255. So if I run this again, this is now changing. This is not that 0000000 we're supposed to be getting. I'm modifying it. And that's defeating the purpose of immutability. This is what we want to avoid. We can fix this first by defining dunder slots as a class attribute. This is a list of strings of the names of the attributes, that is member variables, that you want to allow. You don't have to include your functions on here, your methods, only the instance attributes themselves. So we want to allow red, green, and blue, and nothing else. So if I run this, I now get an error trying to add flurm. And this is important because one of the other advantages here, if I take away the slots again for a second, is there's this dictionary behind the scenes. This is where those instance attributes are actually being stored inside of that object. But when we bring slots into the picture, we're getting rid of that dictionary. And it's using something else behind the scenes that's a lot faster, a lot better performance, and you can't arbitrarily add to. So you cut down on errors. So you can use slots in most cases. I won't go into all the edge cases, but there are some things to bear in mind when using them. But in general, for typical objects, just throw slots on there. No big deal. So I can't add flurm anymore, which is great, but I'm still modifying this attribute. That's not good. So Python exposes nearly everything, nearly all its functionality through these dunder methods, double underscore methods. And we have one called setAttr. So what I can do here is I can take any action I want to before the value is set, because I have to explicitly call on the parent, that's what super's for. On the parent class, I have to explicitly call here we go. I have to explicitly call the setAttr there. So now you see it's telling me every time it's setting an attribute before it actually does it. So we can use this to our advantage. We can say if it does not already have the attribute, we can use the hasAttr function. If self does not already have whatever attribute key is, then we're going to go ahead and define that. Otherwise, we're going to raise this attribute error. I am copying the attribute error used by Python, raised by Python, if you try to modify an attribute on a string or an integer. So now I can no longer modify that attribute after it's been created. I can create it initially, but I can't modify it anymore. So just to prove that, comment that out, and we get 0, 0, 0, 0, 0. However, there is one other run around the rules here. If I delete the attribute first, now I can totally reassign it. That's no good. Well, we have another dunder method called delattr. We can do the same thing. Raise an attribute error. We never want to allow deleting an attribute. When the object itself is torn down, we'll let the garbage collector take care of things. So now I can't delete. I cannot reassign. I can't add arbitrary values. I can only initially assign, and that's it. Once it's been initially assigned, I can't change it after the fact. So I can have as many of these instances as I want, but they're immutable. Now, some smart aleck watching this at some point in the future is going to say, well, all I have to do, Mr. McDonald, to modify your precious class is to say object.setAttr, and then I'm going to pass in the object I'm modifying, the attribute I want to modify, and the new value. And then if I print it out again, how do you like them apples? But I would say if you're getting this clever at this point, you deserve whatever bugs you're going to get. This is not normal Python. Like calling object directly or calling the parent and actually calling dunder setAttr yourself is so strange. You should not be doing this. So it's a little bit like how we don't have data hiding in Python. We don't need it because we have this principle, as it was explained to me. You don't stay out of the living room because I have a shotgun. you stay out of my living room because I asked you nicely. So it's this principle of the programmer probably knows if they need to violate the rules, and they're responsible for the risks if they do. So if you're going to do this, have fun with the bugs. But outside of that, for all normal usages of the class, you have something that is, for all intents and purposes, immutable. And you get some free performance gains from it, which is pretty cool as well. So if you want to see this pattern, this is in the book. One other thing really fast is if you're going to do this a ton, pull the set and del adder out, create a mix-in. A mix-in is just an incomplete class that's got some methods that you might want to share. I can add that, and that does the exact same thing. But I can now create as many classes as I want and apply that immutable mix-in without any trouble. So that is immutable classes in Python. And yeah, it really does work. So yeah, that is objects and functional in Python. So I've got a couple minutes here. If anyone has any questions for that, please go ahead and throw it in the live chat or ask speaker room on Discord, and happy to answer those. I'll keep an eye on that. But while I'm waiting on that, because I don't like asking myself questions, I'll just mention again that that book that I wrote, Did Simple Python, which I described this and much, 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 much more. You can win a copy of that. Enter this raffle here, and you could win a copy. But yeah, that book is available from No Starch Press now, so get it wherever you like to buy your books. And yeah, so I will also be in the Discord. So if anyone has any questions after the fact, you could totally hit me up there or anywhere on the internet. I am CodeMouse92 ubiquitously, so you can find me pretty much anywhere. So yeah, hey, this is a great time for you to go refill your coffee if you are running low on hot beverages. And then we're going to come back in a minute because we have Adam Gordon Bell, who is going to be talking about beating Tim Sort at merging, which I am really excited to learn more about that. So that'll be the last talk for this block. Then we're going to take a break before the next block of awesome talks here at the coziest Python conference in the known universe and parts of the unknown universe as well. I also have to say this even beats all the conferences that they have on Jupyter. We're better than all those. I can say that with expertise. I've been to all of them, and this is the best one. So, all right. So we will be back in a minute. Go get that coffee. My sport background host here is getting, you got so much energy. It must be much early. No, this is just the way I get when I get a cold. I get a little bit loopy. So although some people would like to point out that this is my normal too. So I think just the loopiness and the tiredness are kind of complicating to each other, and add caffeine to the mix, and I'm pretty much insane. So yeah. Uh, so we have Adam Gordon Bell here. Hello, Adam.
Hello, how's it going? I like your energy, man. I think it's great.
Oh, thank you. Thank you very much. So I have to say that I'm geeking out a little bit about this because I love sorting algorithms and yeah, I want to know how this works.
Well, good. I'm glad to hear that. Yeah.
So I will bring up your presentation here if you are ready to roll.
Yeah, let's do it.
All right. Take it away, Adam.
Thank you. Yeah, I'm glad you said, Jason, that you like sorting algorithms and stuff, because I'm going to be talking exactly about that. I want to share a story about investigating a mystery. So I'm going to take you on a little bit of a journey. We'll learn a little bit about sorting and about performance and Python, of course, and a little bit of C code. So I was sitting at my standing desk, as I tend to do because I'm lazy. And I was looking for a solution to a problem, which was merging sorted lists in Python. I was putting together this example code for Earthly, which is an open source build tool that I work on. And like really the code that I put together didn't matter too much because I was more showing off the build process. It's like a proof of concept type of thing. But I mean, I also like sort algorithms and stuff like that. So I started to, just implement some different algorithmic ideas as some example Python code in this build. But then I got stuck on this idea of merging sorted lists. So I don't know if anybody else is familiar, but if you have two lists and they're sorted and you want to make a new list that's also sorted from them, like there's a couple ways to do it, right? Then the simplest way is to just shove those two into a new list and resort that list, right? But I warn you, I'm going to talk a little bit about algorithmic complexity and like big O notation in this talk, but it won't be too scary, I promise. So if you resort that list, even if you have a really great sorting algorithm, it takes n log n time in the worst case. So it takes more than a linear number of steps to do that. But there's a trick to do it better, which is merging these sorted lists. So I'll show you an example of how that works, right? So here, I have my two lists. I have a list with 2, 3, 4, 5, and I have a list with 1, 4, 10. And then this is just the end marker of the list, right? And so I want to produce a new list that's also sorted. So instead of throwing them in a list and resorting it, I can just do the following, right? I start at the beginning of each list, and I see which element is the smallest, and then I just add that to my new list, which I'm placing down here, and then cross out that item, like take it off the list, basically. And then I can just keep doing that. So then I would do my next test, check 2 versus 4, 2 smaller. So I pull that down, cross that off, and I just keep working and working through this list until I've removed every element, and then I'll have a new sorted list down here, right? And the nice thing about this is it's faster than resorting because it takes advantage of the fact that my initial lists were already sorted. So every time I compare two elements, I add a new element to my list. So it ends up being linear time, which is O to the N in algorithmic complexity. So it only takes as many comparisons as I have elements in my final list, which is faster than sorting things, right? So I whip up some code for this. It looks something like this. So my method is called merge sorted lists. I take in 2, L1 and L2, and I have a result list, sorted list. And I basically just loop through it each time, comparing my list and seeing which one has the lower items, right? If the lower item is in L1, then I remove L1 from the list and I add it to my sorted list. If L2 is lower, then I remove L2 and add it to my sorted list. And I have an extra step. So like, let's say when I get to the very end of the list, like after I add 5 here, I have only one list. Like my list here is empty, and I just have a 10 here. So my final step is whatever we have left in either one of our lists, add that onto the final end. So that's my code, right? It makes sense. I did find out, oh, there's a bit of a faster way to do this. Instead of using pop, it's better to actually keep pointers as you're going and go through it. But then a thought came to me, right? Like, I don't really want to own this code for merging sorted lists. Like it was fun to write, maybe a little distraction. Let me put on my kind of like leet coding hat for a couple minutes. But, you know, it's not really what I want to own. I don't want to own this code. So I just decided, like, let me find a package. Like surely there's a Python package where you can merge sorted lists, and then I can just call that. That'll be much easier, right? This is just, if I can not own code, I'll try not to, right? So I head to Google and I Google merging sorted lists. I end up on Stack Overflow. And I find this heap q.merge exists, and heap q.merge does exactly what I'm looking for. It's code a lot like this, except it's more general and it can handle like any iterators. So that's awesome. I don't have to use my code. I mean, I wrote it, but whatever. It's better to use something established. But then I look in the answers in Stack Overflow and I see somebody's answer that says, long story short, unless your list is how many elements? I think this is 1 million, 6 zeros. Unless your lists are more than 1 million elements, which they're not, you should just sort it. So that's kind of a weird statement to have. And because it's Stack Overflow, there's like comments below and there's people fighting about whether that's correct or not. And certainly to me, it seems really wrong, right? Like as I just explained, it's faster to peel off elements one by one and take advantage of the fact that it's sorted. It's way faster to do that than to, you know, just resort the whole list. So basically, I found somebody who's wrong on the internet, and it's time for me to prove it to them. So now I have another tangent of a tangent. I start taking this code, comparing this sort to the heap .merge, and I can see what that's going to look like. I can pull in matplotlib and I can do a little graph, and I can see, you know, that this is faster. And so that's what I do. But it doesn't work out so well. So here's my graph. It's a little bit confusing, but my resorting, as recommended on Stack Overflow, is here with the triangles. And these are like this as the size of the lists grow. The heap merge, which does things the correct way, I'm going to say, is in the blue. And this is time going up this side. So it is always, in every case that I tested, slower to use the more, you know, algorithmically correct way. Strange, right? This doesn't make sense to me. And you can see that these lines are getting closer and closer together. So probably that person was right. Somewhere on a long enough list, it'll actually get bigger. But this is very odd, right? I don't understand this. It makes me question everything I know about how computers work and like what Python's actually doing behind the scenes. So what I do is I just decide to grab some lunch, let this simmer, and yeah, I go downstairs, I grab some lunch, I bring it back up to my desk, and as I'm eating, I start reading through how this works, right? And I discovered that sort method, which seems to be a lot faster than it should be, is timsort. And this is the commit I found. This is Tim's original commit. Tim Peters created timsort, and he committed it in July 1st, 2002. The commit message is kind of funny. This is actually just a text file describing timsort, and he put in the thing here, there's way too much here to stuff into code comments, and lots is going to be useful again, but I don't know what. So here's just a giant dump of my thoughts, right? So I'm sitting there eating lunch, being this is weird. And so I pull up his file that explains timsort, and it's a text file, and it's quite big. And it starts off, this describes an adaptive, stable, natural merge sort, modestly called Tim sort. Hey, I earned it. So he names it after himself. And then he says it has supernatural performance. Supernatural, not a term I'm used to people saying in association with sorts. And it goes on and on. I scroll down further. By the time you get to line like 400, he introduces something called galloping. Also something I've never heard of when it comes to sorting. And then it just keeps going. And then there's like galloping with a broken leg. There's various merge algorithms, merge high, merge low. There's galloping complications. It is a lot. Tim sort seems a lot more complex than the kind of like quick sort and merge sort that I was used to learning about. But eventually it starts to make sense to me when I understand that Tim sort is based on merge sort. And a merge sort works like this. Like here I have this list, 100, 200, da, 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 da. And I want to sort it. And so merge sort will break it up into single elements, and then it will merge those elements. And as it does, it sorts them. So it's always taking lists and joining them together as it sorts them. And so if it had two chunks that were my 100, 200, 300, and this 1, 2, 3, 4, it would basically do the same thing I described before. It would compare the 100 to the 1, see the 1's lowest, pull it down. Compare the 100 to the 2, see the 2's lowest, and pull it down, and so on and so forth. As it slowly pulls all these elements in, it will sort those two merge portions and make a new sorted list. That's merge sort. But what Tim sort has is this idea called galloping. So in most cases, Tim sort follows the same merge sort algorithm, except in these steps we were in here, where we're pulling in 1, 2, and 3, 4. You might have noticed that because this is 100 and this one has a lot of elements, we're going to just keep pulling from this one side. So we're going to compare 4 to 100. We're going to compare 5 to 100. We're just going to keep comparing each number in here back to 100. So Tim sort introduces this idea, it says galloping, that says once I start pulling from the same side a certain number of times, let's say like 7 times, like something is going on here. There's a big gap. And so it starts galloping. It starts looking further out into this list and saying like, how far out in this list on the right would I need to go before I get to 100, right? So it starts jumping out, kind of doing a binary search, going out this way, looking for bigger and bigger elements. And when it does that, it's able to skip a lot of comparisons and find that somewhere in here, right, we go from 4 to 100, and that whole 4 to 100 chunk can be moved down in one step, right? So that's a gallop. It gallops out this way, and then it pulls that in. And that means it's able to save a whole bunch of comparisons against 100, which is pretty cool. So by this time, my lunch is kind of over, and I've kind of just like drifted off into the afternoon of going deep on sorts. But I've learned a lot. I learned about Tim Peters. So this is him here. It's a picture of Tim at a PyCon conference where he did an interview. And the timeline of Tim sort is kind of interesting. In 1993, somebody wrote a research systems paper about optimistic sorting. And it covered a lot of interesting ideas, one of which was galloping that we just discussed. Another one was the observation that in real world data, like sort algorithms, we measure them using this big O notation, which is about the worst case performance. But in the real world, the worst case doesn't happen very often. And another observation of this optimistic sorting paper was that, hey, a lot of real world data is already partially sorted. It's got some sorted chunks in it. And so it introduces this idea of like, if we can already find those pre-sorted chunks, then when we do our merge sort, we can just start with them and it will make things a lot faster. So anyways, that's an academic paper, but Tim Peters reads it. And in 2002, he introduces into CPython Tim sort. And that was that giant document that I shared. He really went deep, making sure that the sort was faster in all the cases that the Python developers would care about, and introduced it. It worked really well. And in 2009, Java looked their head up at Python and said, we're going to take that as well. And so the same thing happened with JavaScript and with Swift and with Rust. And now it's to the point where in any language, when you reach for a sort algorithm, if you don't specify, you're probably getting timsort. So this is all really cool, but it still leaves me confused, right? Because here's the thing. I'm not resorting a list. Like, this is cool that timsort beats quicksort or merge sort, but I already have sorted elements. So I don't see why timsort, this list.sort in Python, should beat the performance of my merge, right? So I start digging in further. Now we're on a tangent of a tangent of a tangent in terms of what I was actually working on. But I find the code for timsort is also in the commit. And the one thing I notice is it's all written in C, where my algorithm and the heap.merge are written in Python. So maybe the issue here is actually that timsort is faster than my merge, in part because it's written and runs natively in C, where this is interpreted, right? So this, I put a little cartoon of me thinking about this here, but this gets me thinking, right? It gives me this idea because, you know, I was working on this example for Earthly to show some Python code building, but I have more examples to do in the future. And one of them is building, you know, a cross language. And wouldn't this be a great example? I can write some C, I can port my algorithm down, and I can show how you can do great, like, reproducible cross language builds in Earthly. Therefore, you know, chalking up all my weird tangent into digging in on sorts as like actual productive work. But also, if it's faster, like, people are merging sorted lists all the time in Python. And so I can put it in a package and I can release it, and then there'll be less CPU cycles, you know, based on this, and, you know, less greenhouse gases emitted, and global warming will end, and people will have a parade for me, and I'll save the day. Maybe that's a bit unrealistic, but sometimes when I have an idea, I get really excited about it, and I just want to dive in. Anyways, so that's what I do, right? I take my algorithm and I port it to C. I did actually have to reach out for help with somebody else on my team who's more familiar with C, but get in the Python headers, and the code is actually not too bad. It's not too much different than I thought it would be. This is something I've never done before, so it was a bit of an adventure for me. But yeah, the code here, I basically make a new list that's the size of the two input lists, and this is like my while loop from before. I pull the items off of each list using this pylist.getItem, and I compare them. And if it's smaller, I set it back in. It's basically the exact same thing as before. Down here is the, you know, when you get to the end of one of the lists, you add everything back in. Simple, right? Well, it scared me at first, but it actually worked out to be not too hard. And then once that's all built, I can just import it and call my merge algorithm, and then hopefully I'll have some faster code. So I also have to put together a build for it. So this is my Earth file. It's kind of like a multi-stage Docker build, but it does a great job for building these Python packages. You can see here I'm copying in the setup code. This is my merge code here, merge C, my headers, binding, build everything together. And then I have a performance test, which is how I made that original graph, right? So I'm just going to call both, and I'm going to actually, this just prints them out, but I'm actually going to graph them out so that I can see that nice graph of how it's performing. And so with that, I test it out, right? And oh, it works, which really surprised me, honestly. But this list A plus B sort is in the blue, so you can see it's higher. Basically all sizes of lists. My merge algorithm that's also written in C is much faster. This gap represents saved compute time, right? So this is awesome. Maybe I can actually do this. Maybe I can drop down to C and write some performant code for kind of these hot loops. Or at least that's what I think, because the next thing that I do is I test another example. So here I put together a list of ints. My previous one was a bunch of objects. I put together a list of ints and I compare them. And you can see, if you look down here, I'm actually slower for a while, and then it gets kind of neck and neck even. And I don't know, it's hard to say who's the winner or the loser, but it's clear that even though TimSort is doing a lot more work because it's resorting the list, that I am not beating it, which is strange, right? So I'm still a bit confused about what's going on here. So, in for a penny, in for a pound. So I keep digging in, right? And I find in the code for TimSort, it has these custom comparators. I'm not totally sure how you pronounce that word. Comparators, let's go with. So TimSort has this idea. I mean, Tim worked on a lot of the internals of Python, so he knows this stuff well. But big O notation is about how many comparisons you're doing to sort the list, comparing X to Y, how much will happen. But not all comparisons are made the same. In fact, like if I am comparing to Python objects, it may be a complicated operation to tell which is bigger than the other. But if I'm just comparing to integers and they're just like native ints, that's very fast to compare. Same if it's floats or if it's just Latin strings. And so Tim added all these special code paths to handle special types of operations. Basically, if you're sorting a list that's all integers, it's going to be way faster than sorting a list of objects. It's going to be way faster to sort a list of all floats than it is a list of floats and ints. Because when TimSort goes through this list looking for strings that are already in sorted order, like it looks for continuous sorted elements, it also notes the types of all these things. And if the types are all of one of these base types, int, float, or string, it uses this faster code path. Okay, so this kind of answers my question, right? Like, why is TimSort still beating me or neck and neck with me, even though it's doing more work? Because just to restate it, like TimSort is resorting everything, but I am just starting with 2 sorted lists, so I should have less work to do. TimSort can go through and find that my list has 2 sorted, my list is made up of 2 chunks, both of which are already sorted. But to do that, it has to go through the list and find them where I already have them, right? So I should be able to beat it. So I add these methods. I add custom comparisons to my merge algorithm. And then I can test it again, right? So I test it again, and now we're talking, right? The world makes sense, and doing a merge, I can finally beat a sort algorithm. So you can see here the specialized merge for ints I've put down here at the bottom, and it can now beat the TimSort that's been specialized for ints, as well as my more general merge. And this works for all cases. So now, this merge is beating TimSort at merging for all cases. So pretty cool. It actually worked out. And I ran with this, right? I wrote it up as a blog post. I put the examples. I put it on Earthly's blog. And I said, look, TimSort's really cool. Here's all the cool things it does. But look, I can beat it if you're already merging sorted elements. And when I did this, it got some attention. It was on Hacker News, some people fighting about various things. But somebody interesting saw it, which was Tim Peters. And he reached out to me, which I thought was really cool because he obviously knows way more about all of this than me. And he said, this is great. You beat TimSort. But what about the galloping? Because if you remember that galloping step that I talked about at the beginning, it's actually during the merge part of the merge sort. And so I can use that in my merge. I could take his galloping procedure and I could make a Tim merge, which would be even faster than my existing merge. So I did not do that. That was more work than I had already spent on this tangent. But I wanted to share the story with everybody and say, like, hey, the code is up there of this merge. And, if you're ever interested in playing around with writing some C and using it in Python, like maybe you could help me add galloping to merge. And then we could have a true Tim merge, which would be pretty exciting. Yeah, so that was my adventure with sorting. And I don't know, it was fun. I learned a lot of things. One of them is that writing native C code is actually not as hard as I thought it would be. Like it was challenging because I don't really know C, but it made it work and it was faster. Python is pretty performant most of the times, but it's a neat skill to drop down. The other big thing I learned is just the Tim sort is really cool. Tim Peters put a lot of thought into making it so this like common operation, just calling sort in Python, really works really well and really is performant. So much so that all these other languages had to pull this feature in because they're like, this is amazing. The other thing that I learned that I'd like to pass on to everybody else is to like pay attention to your intuition. This whole like tangent of a tangent of a tangent I headed on actually turned out being pretty fun and interesting. And I only got there because I was like, that's strange. Wait, this person's talking nonsense. And I dug in and I peeled back the layers and I figured out what was going on, which is another big lesson, right? Like, don't be afraid to dig in a little bit deeper and see what's going on underneath the covers because you can learn a lot. So that's what I'd like to pass on to everybody. Like, just don't be afraid to dig in there and get into the weeds. It can be a fun adventure. And that's all I got. I'm Adam Gordon Bell. If you are interested in this, reach out to me. And check out Earthly. It's pretty cool. I cannot hear you, Jason.
Okay, can you hear me now?
Yeah.
All right, awesome. Thank you so much. Wow. I love that. I was waiting for galloping to be brought up. Like, you should use galloping here. First, Tim would bring that up. That's fantastic. No, I kind of gotta go faster. I love it. Yeah, sorting algorithms are strange, but I'm glad you brought up the intuition thing, and and the fact that implementation matters.
Yeah.
How you implement something actually matters.
Yeah, it was interesting to me because you learn about like, oh, what's the complexity of this thing, and that hides a lot of details, right? And Tim, knowing the internals of Python, was able to say like, oh, we can do better. We can make the operations faster, and he did a lot of cool stuff.
Absolutely. We do have a question, actually. Yay. Moriarty asked if Python recorded ranges of a sequence that were invalidated on any modification, could the built-in sequence.sort specialize to the algorithm you're using? Or is that the galloping variant already does?
I don't know.
I'm going to actually repost that because I was in Discord. I'm reposting that here, and I'm going to display it.
Wow.
Like that, although it's in two parts.
Validate.
The other half.
Could it specialize to the algorithm you're using? Well, you're throwing away the fact that it is a list. Like if you have two sorted elements and you throw it in, you're adding those two together, and so it needs to go back through the list to find those sequences where they're actually in sorted order. So you just lose on that pass through, if that makes any sense.
Waiting to see if. Oh yeah. Oh, hold on. He's typing. So get the response in just a second here. And he said that were known sorted and validated. I'm just kind of posting this in here just to make it.
Yeah. If I understand the question, which is it's totally possible I don't. The interesting, there's another part of Tim sort besides the galloping, which that it does a pass through the list to identify already sorted subsequences, right? And so part of the reason it's able to be so fast and it was so hard to beat it is because when I take two sorted sequences and combine them, I'm throwing away that they're two sorted subsequences. But Tim sort then does a pass and identifies that there actually is two sorted sequences, and then it can start the merge from there. But it has to do that full scan through the list to determine that. And that's how I beat it, is I don't have to do that scan because I'm not throwing away the fact that they're two sorted subsequences.
It does lead to an interesting thought randomly out of the blue, as if we ever kind of make you think, well, what would happen if we instead added to the standard library the ability to pass an explicit assumption? I wonder.
That would be cool. Yeah.
Assume this is sorted or pass these or something like that. But at the end of the day, that would be as much work as what you're doing. And I mean, yours is cool. At the Galpino, that would be a blast. By the way, in case anyone, hold on, actually, we already said in principle, I think Python could not throw away the knowledge that lists were sorted before being combined.
Yeah, that would be cool.
Yeah. On the topic of sorting algorithms, by the way, while we're geeking about TimSort, have you heard about the other fastest? There's two fastest algorithms out there right now. There's TimSort, which is especially for stable sorting, that is, it's safe to use with linked lists. And then for unstable sorting, there's something called dual pivot quick sort. Have you ever played around with that at all?
No, I'm familiar with quicksort, but yeah, so I assume dual pivot just does it too quick, like it starts with two pivots?
Yeah, there's a paper by Vladimir Yaroslavinsky who developed it for Java. It's mind-blowing when you wrap your head around it. So I just want to throw that out there too.
Very
It's
cool.
like I'm curious which one would win in a race now. It's like if we did DPQS and TimSort, which one would actually be faster? Yeah, and now I want to know. If anyone else has any questions for Adam, he will be in the Discord channel, so check him out there. Thank you so much, Adam. That was fantastic.
Thank you.
Awesome. So we're going to be taking a break here in a minute. I will I'll be coordinating with the next host, Christian here, who's going to be taking over after the break. It's got some awesome talks coming up in the next block. Definitely stuff that you don't want to miss if you are still awake. Async database, SQL and Python, graph databases, GraphQL, data analysis. So it sounds like some really fun data-oriented stuff. There's something in there about refactoring, something about Kivy, which is an interesting GUI library. So there's cool stuff coming up. So if you're awake, check it out. If you're not awake, go refill your coffee, come back and check it out, because this is an awesome. There's some awesome talks. So yeah, thanks for joining us at the coziest Python conference in the known universe, and we will see you back after the break for some more. Oh, and hey, don't forget to enter that raffle for Dead Simple Python. So if you haven't done that, enter there. Awesome. Win a free copy. So we will see you all after the break.